Hello everyone, welcome to Code Rules. We will see the Java 8 features full course here. The topics we will be covering in this course are as below. First, we will cover the Lambda expressions and then functional interfaces. We will see some predefined functional interfaces like Predicate, Function, Consumer, Supplier. Then we will see the method reference and constructor reference using double colon operator. And then we will see the most important topic, streams. In streams, we will see the intermediate operations and terminal operations. Then we will cover a simple optional class and then Java 8 date and time API. So in Java date and time API, we will cover the local date, local time, local date time, period, duration, these classes. And for formatting, there is one class date time formatter. So we will see all these topics and let's move to the Lambda expression. In Java 8, Lambda expression is an anonymous function. Anonymous means not identified by name. So we can say Lambda expressions will not have name, modifier, and a return type. So let's see what does it mean. So we can see like Lambda expressions will not have name, it will not have any modifier, and also it will not have any return type. We will take one example to explain these things. So I will write one method which will simply print hello world, and then we will create a Lambda expression for that. So let me take one method here, public void hello. And I will write a sysout statement here. I'm taking a shortcut, but you can write the full form like system.out.println. Okay, hello world. Okay, now this is the method which will print hello world. Now I have to create a Lambda expression for that. How can we create? Like as I have told you before, Lambda expressions will not have any name. Also, it will not have any modifier and it will not have any return type. So we will collect all the remaining things below. And what we have now is parentheses and curly braces and our sysout statement. Okay, and curly braces close. To make it a Lambda expression, the important thing is we have to pass an arrow here. Okay, now this is a Lambda expression that we have created for this method. This is our Lambda expression for this method. We will take another example. So now I will create one method which will take two parameters as an input, and we will return its sum. So my method will be like public. We have to return sum which will be int type, so return type as int, and the name is sum, and we will take input two parameters, that is int a and int b, and we will be returning the sum. Return a plus b, that's it. Now this is the method which will take a and b as an input and it will return its sum. So how can we create a lambda expression for that? So as I have told you before, there will be no name, there will be no modifier, and also there will be no return statement, return type, like, and we will collect all the remaining things below. So what all the things are remaining are int a and int b. These are the input parameters, and what are other things are like, okay, let's make it some space. Curly braces open, a return statement a plus b, okay, and curly braces close. Okay, but as we have seen, to make it a proper lambda statement, we have to pass an arrow here. Okay, now this is a lambda expression that we have created for this method. Again, we will take one simple example to, like, with one parameter. So I will take one string str as an input and I will return a simple length of the string. So what will be my method? It will be public int and the name should be len. It will take one parameter as an input, which is the str, and we will write a return statement str dot length. Okay, now this is my Java method which will take string str as an input and it will return its length. Now I have to create a lambda expression for that. So we know that there should be no name, there should be no modifier, and there should be no return type, and I will collect all the remaining things below. So what are the all remaining things? It is parentheses and type string str. I'm making some spaces here so that, like, I can explain you in a better way. And other things are like return statement, return str dot length and curly braces close. And to make it a proper lambda expression, we know that we have to pass an arrow here. Now this is a lambda expressions that we have created for this method. Okay, so for now we have seen 3 examples, and like we have created a lambda expressions for the respective methods, but we can optimize this lambda expressions further. And to optimize this lambda expressions further, we have some set of rules. There are 4 simple rules that we can use to optimize this lambda expressions. So let's see these rules on the presentation, and then I will try these rules with these examples. So we will go back to presentation. Okay, so the first rule is, if there is only one statement, the curly braces are not required. And the second rule is, no need to specify the type for parameters. While writing Lambda expressions, the Java compiler will automatically detect the type of parameter using context. There is a concept called type inference, and it will automatically detect the type for parameter, so we need not to specify it. The third rule is no need to write return state, like return keyword. So no need to write a return keyword. And the fourth and last rule is if there is only one parameter, even the parentheses are not required. We have taken one string as an input str, so it is only one parameter, so even the parentheses are not required at that example. So these are the 4 rules, and we will apply these rules in our previous examples to optimize this Lambda expressions. So we will go back to the screen, and this is the first example that we have seen. And what is the rule? Like if there is only one statement, the curly braces are not required. So we will remove the curly braces here, like we can. So what are the remaining things here? It will be parentheses, arrow, and sysout statement. Okay, now this is our optimized Lambda expression. Now we will move to the second example, and again, if there is one statement, no curly braces are required. We will cut 8, no curly braces. What is the second rule? We can see what is the second rule. No need to specify the type for parameter. So here we have 2 parameters A and B, and no need to specify its type. Java compiler will automatically detect its type using the context. So we will cut this. What is the third rule? No need to write return keyword. So in this particular example, we are returning the sum of A and B. So this is the only statement here, and if we are doing something and there will be some result, it will be automatically returned. No need to specify or write a return keyword. So we will cut this also. Okay, and what is the fourth and last? If there is only one parameter, but now here we have 2 parameters, so parentheses are required. So we will collect the remaining things below, and what are they? Like A, B, these are the 2 parameters that we have taken, and arrow, and what will be A plus B. You can see we have very simplified the Lambda expressions. Now this is the final Lambda expression for this method. So you can see that this is the Java method that will take int A and int B as an input and return its sum. Then we have written a Lambda expression for it, and using some set of rules we have optimized this Lambda expression here. Now we will move ahead to the next example. So here we have taken string str as an input, and we have written a Lambda expression for it. Now using the same set of rules, we have to optimize this Lambda expression. So what we can do is okay, so if there is only one statement, curly braces are not required. So we have only one statement here, right? Second type is the type of a parameter is not required. The compiler will automatically detect it from context. So this is not required. And as we have seen the third rule, no need to write return keyword. So even the return keyword is not required. And the fourth one is like only one parameter, then parentheses are not required. So we can see here we are taking only one parameter str, and so parentheses are not required here. So we will collect all the remaining things here, and what are they? Only str, which is our parameter, and arrow, and it will be str.length. Right, we can read it like str or str gives str.length. Now this is an optimized lambda expression for this particular method. You can see that this is the method which will take string as an input and we are returning its length. Now, this is the Java code for before writing lambda expressions. We can create a lambda expression from it, and with some set of rules we can optimize this lambda expressions, and you can see a clean and more readable and maintainable code using the lambda expressions. So we have seen 3 examples. So this is the first example that we have seen, this is the second example, and this is the third example. So like you can see that using lambda expressions we can write some more readable, clean and concise code. So this is the advantages of lambda expressions, and our final slide about this lambda expressions can be advantages. And what is the advantages? Like we have seen, it enables the functional programming in Java. So whatever we are writing as an like parentheses and it arrow and the statement ahead of it, it is a like functional programming pattern which is enabled by writing lambda expressions. And like we can write some readable, maintainable and concise code. And if we want to use some APIs, like we can use it easily and effectively. Now if like I will explain this later in coming videos. So like to revise and to sum up, you can see that lambda expression is an anonymous function. It will not have name, it will not have modifier, it will not have return type. And we have seen these 3 examples, like how can we create a lambda expression for the methods. In this video we will see functional interface. So what is the functional interface? An interface with single abstract method is a functional interface. A functional interface can have multiple default methods or multiple static methods, but it should have only one abstract method. Then we can call this interface as a functional interface. And there is one annotation at the functional interface. It is always recommended to use this annotation. So whenever you create an interface, it is always recommended to use this annotation over that particular interface. So I will open Eclipse and I will try creating one functional interface, and we will discuss more things while creating it. So this is an Eclipse IDE and I have created a simple Maven project. Now you can see it is a Java 1.8 JRE library here. So we can create functional interfaces and have default methods and static methods in it. Now if you are wondering like what are the default methods and static methods, do not worry about it more. Like we will cover these topics in coming videos. So for now, just make a note that an interface with single abstract method is a functional interface, and it can have multiple default methods and static methods. So let's create one. I will create a new an interface. I will give it a name as a simple. Now this is a public interface here, and I can add one abstract method. So public void, I will give it a name as method1. Okay, now this is fine. Now this is a functional interface, like it has one abstract method. But as we have seen in the previous slide, it can have multiple default methods and static methods. So let me try creating one variant of it. So I will create one interface. I will give it a name simple2, and it will have one abstract method. So let's say method 2. Okay, and also we can add default method. Now here the business logic goes, and for now we will not worry about it. Also I will create one static method. So public static void, and we will give it a name method4. Again, the business logic for this particular method will go here. We will not write it out for now. So this is also an example of functional interface, because it has one abstract method, and it has one default method, and it has one static methods. So we do not care about the number of default method and static methods. What we care about is there should be only one abstract method, and it is the method 2 in this case. Okay, so this is an abstract method here, and that's why there is only one, and that's why it is a functional interface. Now let me try creating a variant of it, and we will add multiple. Like I will create an interface 3, and it will have one abstract method. Fine, I will create one more default method. Again, I will copy the static method. I will create one more static method. I will change the name. Let's give a different name to these methods. Okay, now this is also a perfectly fine functional interface. What is the case here? Like there should be only one abstract method. There can be multiple default methods, no issue. There can be multiple static methods, no issue, but there should be only one abstract method. As we have seen in the slide, there is a functional interface, @functional interface annotation, and it is always recommended to use this @functional interface annotation. So we can see I have added it here, but what is the use of it? Because even if we are not specifying it here, the interface will be functional interface. But when you are working with teams and multiple members are working on the same project, like if you have created some functional interface for your use case, and if some member trying to add a like abstract method in it, there should be some restrictions, like, and this particular annotations will give compile time error when if a user will try to add more than one abstract method. So let's say like I will try to add one more abstract method here. And I will save it, and you can see a compile time here. It says invalid functional interface annotation. Simple is not a functional interface. That means whenever we add more than one abstract method, the interface will not remain the functional interface, and that's why it is giving us a compile time error. So like if we removed it, then it will be again a functional interface, and you can see the compile time error is resolved. And that's why like the functional interface annotation is always recommended to use. Even if we removed this particular abstract method and we save it, then there will be again an compile time error, like invalid functional interface annotation. Simple is not a functional interface, because the condition is an interface, there should be single abstract method, and whenever we add it, again the compile time error is resolved. Now it is a functional interface, and you can add this annotation on the below interfaces as well. So it is always recommended. That's it. Now we have seen like how can we create a functional interface and what are the various cases, conditions for it. But what is the use of this particular functional interface? As we have seen in the previous video, we have created Lambda expressions for our 3 examples. So to use or to invoke these Lambda expressions, we can use functional interface. So we can say a functional interface is used to invoke the Lambda expression. A functional interface is a type of Lambda expression. So if you do not understand the second statement, do not worry about it. We will write down it in coming videos and you will understand it. Just mention like remember one thing, that functional interfaces are used to invoke the Lambda expression. Now we will create one example and we will try to understand these things. So let me open my Eclipse IDE, and this is a simple Maven project, and I will create one class here. So I will give it a name as date1. I will add the public method. So the idea is that first I will not use the Lambda expressions, and in the next example we will use the Lambda expressions, and we will compare both and we will see how Lambda expressions will make our things easy. So let me create one interface here. Let's say printable, and it will have one abstract method print. Okay, so this is an interface and it is on one abstract method print. Now I need one class which should be implementing that printable method, so that I can override this print method in it. So I will create one class. So let's say class print class, and it implements printable. Okay, now this says like implement the all unimplemented methods from the printable. So I will just click here, add unimplemented methods, and we need to override this particular method. So I will simply write one sysout statement here, not any complex logic. That's it. Okay, now this is an interface where we have one abstract method. So since it has only one abstract method, it is a functional interface, and we have one class, print class, which is implementing the printable, that interface, and we have overwritten the logic here, the print method. So if, and this is our test class. So if we want to use this print method, we need to create a object of the print class. So how can we create? Like I can take an interface. I can take an interface also. So like let me see, printable print, okay, printable, and we can see like p, and I will create an object of the print class. Okay, so I have created an object of the print class, and now I can invoke the print method. That's it. Okay, so, and I will run this and we can print that logic. So I will, yeah, you can see I have pressed the control plus F11. It is a shortcut to run a class, and you can see the print method logic is printed. So this example is without using the Lambda expression. We can see that I have created an interface. I have created one class which is implementing that particular interface, and we have written a business logic for that particular method here by overriding it. And to use this method, or like we need to create one test class, and in the main method of that particular test class we have created an object of the print class, and by using that particular object we can invoke the print method, and this is how we can like print the print method logic, which is our like statement here. So now this is without using Lambda expressions. Now let me create one with Lambda expressions and we will compare both them. So I will create another class test. Okay, again I will create interface. We'll have one abstract method, public void print. Okay, so okay, it is already defined, so I will create one. I will change the name. This is printable2, and it has an abstract method print, but you can see that this is a functional interface since it has only one abstract method. So in the previous videos we have seen that how can we write Lambda expressions. So let me write one Lambda expressions for that, and we can come to the main method of the test2 class, and I will write printable 2 here, p2, and what will be the lambda expressions. Like it will have the print method is not accepting any parameter, so empty parenthesis, an arrow which is an important sign for the lambda expressions. And what is the statement? Print method logic from like printable 2. Okay, now this is the lambda expressions, and we can simply invoke the print method using p2 dot print. And when I run it, let me run it as a Java application, and you can see the print method logic from printable 2 is printed. So in test 1 you can see that we have to create one class which is implementing printable, and then we have to override the print method and we have to write the logic here. But by using lambda expressions, we can simply write a lambda expression for that particular interface. The condition is that particular interface should be a functional interface, and by using the p2 we can like invoke the print method, and we can print the print method logic from printable 2. Now business logic can be anything, just this is like to understand, I have kept it simple. Now like you can see that this is an interface and it is a functional interface, and this is a lambda expression. Now you will understand the second statement from a slide that I have shared before, that functional interface is a type of a lambda expression. You can understand it, right? So when we go to the Eclipse, you can see this is the functional interface and this is the lambda expression, and we can see that this functional interface is a type of a lambda expression. Hope you understood it. And yeah, so we have seen this simple example where like we have not used the lambda expressions, and we have seen how can we like invoke the print method of the printable, and we will see it with lambda expressions, and we can see basically that we have a more readable and maintainable code is using the lambda expressions and more concise code. Now these are the examples we have seen in the video of lambda expressions, where we have taken some methods. Like this is a simple print method where we are printing a statement, and for this particular method we have seen the example in previous video. Now we will see example for this particular method. Now this is a method where we are taking int a and int b as an input, and we are simply returning a sum. So we have also written a lambda expression for it, we have optimized it, and we can see now this is a final lambda expression for that particular method. So now I will go to the Eclipse and we will write an example for it. So this is an Eclipse IDE, and I will create a simple class test1. Now the approach will be same here as per the previous video, that we will create one without lambda expression and one example with lambda expression, so that we can compare both and we will see how these things will work, like with lambda expression, how our code is more readable and better. So I will create one interface here. let's say SumAble, and there should be one abstract method, so public, and it should be returning an int, right? Sum method, so it will be public int sum, and it will accept two parameters, that is int a and int b. Okay, now this is our functional interface here. Now we need a class which will implement this particular interface. So I will create a class, let's say sum class, and it will implement SumAble. Okay, now we need to override the sum method here. So like you can click the control and 1 to get the all possible options here, and we can see add unimplemented methods. Click on it and you will see the method here. Now what we have to return? We have to return just a plus b. Okay, so now this is the functional interface, this is the class which implement that particular functional interface, and we have overridden the sum method here. We have written a business logic for it. Now this is our test class where we are going to test these particular things, and if we want to use the sum method, what should we do? We should create an object of the sum class. And how can we create? SumAble. Oh, let me correct the spelling. And the same should go here. Okay, SumAble, yes, 1, let's say, and here we will create new sum class, and yes, 1 dot sum, we will pass 10 and 20 here. Okay, but we have seen that it is returning, so if we want to print it on a console, we should like take it in a int, so like result, int result, and we are capturing it here, and I will print that result. Okay, so let me add something like sum is. Okay, fine, and we will run it. So okay, fine, interface is done and the class is done, and then the test class is done. Let me run it, control and F11. Yeah, sum is 30. So we have passed 10 and 20 and we are getting the sum 30. It is perfectly fine. But as we have seen, this is without using the Lambda expression, and we have to create an interface which is a functional interface, or in that case it doesn't matter at all. And this is a class which should be implementing that particular interface, and this is a test class where we can use the s1.sum. like we have to create an object of the sum class, and then we can use the sum method. Now let's see how can we do this using the Lambda expression, and we will create one test2 class, test2. Okay, and let's add main method. Okay, and create an interface here, interface, and this should be SumAble. But since we have previously defined it and we are in the same package. Let me make its name different. So it is summable 2, and we should add one abstract method, public int sum, int a, int b. Okay, fine. Okay, we have created a functional interface here. Like this is an interface and it has only one abstract method. This is fine. Now we have a test2 class, and we will go in the main method of test2 class, and we will see how can we use that particular functional interface to write a Lambda expression. So we will see summable 2 yes2 equal to, and we will be writing a Lambda expression for that. So we have seen how can we write a Lambda expression for that particular method, right? I will add the link of this particular video in the description. You can check it and you can come back to this video, so it will be a like good revision. So we will be adding parentheses since we have two parameters here. If there is a one parameter, no need to add the parentheses. You can remember the rules for the Lambda expressions, right? And the next important part is arrow, which is a sign of the Lambda expression. And here goes the statement a plus b. We want to return it, but since this is the only statement and it is providing the result, it will be automatically returned. No need to add a return keyword here. Okay, now this is perfectly fine, and we can invoke our sum method now. Now this Lambda expression here represents the sum method implementation of a functional interface. So I can easily invoke the sum method, and I will pass here, let's say, some different values, 45 and 30. Okay, again it is returning a value. No, I need to capture it. Let's say result 2 here, and I will print it. Okay, fine, and I will run it. So let me run. I will clear this console before, so you can simply right click and clear, and now I will run this particular test2.java. So to run, you can either right click and run as and then Java application. This is a like traditional way to run the Java application, or you can use the shortcut. What is it? Control plus F11, and it will run the shortcut. So we have just printed the result 2. You can see it is 75. So 45 plus 30, 75 is printed on the console. You can see it. So here we have used the Lambda expression, and you can see the code is very concise. It is more readable and maintainable code. In test 1, we have to compulsorily create one class which should be implementing an interface, and then we have to override the logic. In test 1, we have to create an object of the sum class, and then we can invoke it. But in test 2, where we are using Lambda expressions, we can easily write a Lambda expression for that particular functional interface. The only condition is that interface should be functional interface. That means it should have only one abstract method, and we can write a Lambda expression. Now this particular Lambda expression represents the logic or the implementation of the sum method. And now we can invoke the sum method using yes2. We will capture the result here and result 2, and we are simply printing it. That's it. Thank you. So for now we have seen 2 examples. Again, we will see one more example in the next video, and you will be more clear about the Lambda expressions. We have seen 2 examples for the Lambda expression. In the first one, we have just printed the simple statement, a sysout statement, and in the second one we have taken 2 parameters as an input, int a and int b, and returned its sum. In this particular example, we will take one string as an input parameter and we will return its length. Now let's see this particular example in Eclipse. So I will move to my IDE and I will create one class. So the approach will be same here, that first we will create demo 1 example without using the Lambda expression, and I will create another one with using Lambda expression. So we will compare both the examples and we will see how Lambda expressions will make code better, more readable and maintainable. So I will create one sample interface here. So let's give it a name like length interface. It is a simple name, no need to worry about it for now. And it should have one abstract method. So we will be taking one public int, since we are returning the length of the particular string, and the method name is len, and we will be taking one parameter as an input, so it will be str, string str. It's fine. This is perfectly fine functional interface. And now we need a one class which should be implementing that particular interface, and we will override the len method in that class. So I will create one class. So let's give it a name length class. I'm giving any random name for now, just don't have to worry about it. And it should implement length interface. Okay. And to see the all possible options, like you can hover on it or press the Ctrl+1 and you can see the all possible options. So the first one is like add unimplemented methods. Since we have to override the len method in length class, we will click enter and it will add the len method here. So I will remove the comment and we will be simply returning the length of the string. So we have a function called string.length and I will be returning the length here. Fine. So we have written one interface, we have created one class which will be implementing that particular interface, and we are overriding the len method in it. Now to use the logic of the particular len method, we should have one object of the length class. And how can we create it? By using the demo1. Now this is our test class for us, and in the main method of test class we will be creating one object. So let's say length class. You can take a length class also or length interface also, no issue. Use the new keyword and length class. That's it. Now we will be invoking the len method. So len, and we will be passing one simple string here, So let's say CODEROLLS, code roles, and it will be returning a length of that particular string. So we need to assign an int variable here. So int str length equal to, now this len method will return the length of this particular string, and we will capture it here and we will print. Okay, so I am simply printing it. So an interface, a class which is implementing that particular interface and overriding its method len. And this is a demo class where we have created an object of the length class. We are invoking the len method using that particular object, and we are storing its length, which will be returned by the length method in str length variable, and we are simply printing it on the console. So we are ready to run. So how can we run? By using the run as a Java application, or we have a shortcut control plus F11. So we can see the length is printed on the console. Str length is 9, and we can see it is 9, right? But this is the normal implementation, that it needs an interface, a class which is implementing that particular interface, again a demo class where we are creating objects and then invoking the len method. So this is the normal implementation. We have a better approach than this. So what is it? Using the Lambda expression. Now we will create another class, demo2. I will add the main method, and let's remove the comment first. Okay, so we need a functional interface here also. So I will create one interface. Let's give it a name, length interface. And since we have one with the similar name already defined in demo1, I will make it 2. And there should be one public abstract method. So it should be like public void, no, it should be int. Since we are returning the length of the string, it should be int. The name of method is len, and we are taking one parameter as an input, that is string str. Okay, this is perfectly fine. Interface, a functional interface here. Now we have seen how can we create a Lambda expression for that particular method, right? Now this method has a similar representation using Lambda like this. We have seen this. I will add a link of this particular video in the description. You can watch this video and come back to here so that you will have a great revision. And now we will create a Lambda expression for it. So I will write length interface 2 L2 is equal to Lambda expression. Now we are having only one parameter. That means no need of parentheses, only str gives. This is the arrow. This symbol represents the Lambda expression. What we want to return, its length, str.length. That's it, simple. We have written a Lambda expression for it. So this particular Lambda expression is representing the implementation of the length method, the len method. So we have a L2 here, and we can use the L2 to invoke the len method. and we can pass some different string here. Coderoles.com. Okay, so this particular len method is returning and length of this string, so we will store it in a int variable like str length 2. Okay, and we will simply print it. Okay. And we are ready to go. So before running the program, let's check that we have a functional interface. We have written a Lambda expression for that particular functional interface, and we are using the L2 to invoke the len method, and we are storing its length, which will be written by the len method, and we are printing it. That's it. So let's run. What is the shortcut for running this particular demo2.java? Control plus F11. That's it. str2 length is 13, so it is printing the length 13. So we have seen both the approaches for this particular example. You can see the demo 1, and here we are creating an interface, then creating a class which should be implementing that interface, and we have to override the len method here so that we can write a business logic for that. And then we will be using demo 1, where we are creating object of the length class, and then we are invoking the len method using that particular object, and we are storing that in an int variable, and we are simply printing it. That's a normal implementation, and which is lengthy one. The better approach is go with the Lambda expression. So we do not need any external class which will be implementing that particular interface. The only condition is that particular interface should be a functional interface, and when we call an interface as a functional interface, only when the interface has only one abstract method, single abstract method. It can have multiple default method or static methods, so we should not care about it for now. We will take care of it in coming videos. So this is a functional interface, and this is our demo class where we are using Lambda expressions, and we can get the length. So this is simple and more readable. Now we will be taking a new example. So we will see how can we use Lambda expression with collections. So basically we will be printing the list of employees in ascending order by its ID. So we need to create an employee class, its object. We will be adding this object into the list, and then we will print it in ascending order by its ID. So let's see this example in the Eclipse. So we will create one employee class. Okay, and I need ID and name, so I will add it private integer ID, private string name. Okay, fine. Also we will need a constructor, so we will create constructor using fields and its getter and setter methods. So let's create it. Select all, generate. Also we will be printing this employee objects, so we need to override the toString method. So let's override it, and it looks fine. Okay, now our employee class is ready. As we have told you that we will be sorting these employee classes, so we need to compare it. And how can we compare multiple user defined classes? We can use the comparator interface. So basically we can create custom comparator classes which will be implementing the comparator interface, and we will be overriding the compare method in it, so that we can write a custom logic where we can compare employee objects using its ID or name or any data member. So let's create a custom comparator class, and I will give it a name sort by ID. And we need to add an interface. It is comparator. Okay, and we will be comparing the employee. So let's add employee here. Save. And we need to add the unimplemented method. Of course, it is a compare. Okay, and if you want to read about it, how this compare method works, you can check the Java docs. I will share the link in the description, and you can read about it, and you will get to know like how it works. So basically this O1 is an employee 1, so we will get O1.getID minus O2.getID. If the ID of O1 is smaller than O2, we will be getting a negative return. If both the IDs are same, we will be getting 0. And if ID of O1 is greater than the O2, then we will be getting a positive return. So let's write this compare logic here, and now we will be creating a test class. Okay, I will add the main method. Okay, so what things we have to do here? We have to create an array list, create employee objects, add employee objects to the list, and then sort it in ascending order. Okay, so we will create one array list here. Array list of employee list, new array list. Okay, fine. And we will create a few employee objects. So employee, spelling mistake, E1 new employee of, so ID and name. So I will be giving ID as 101 and name as John. So let's create more. E2 and ID is 103. Name, let's give it a Ruby. ID is 104 and name as Mark. Okay, and give a name. Okay, so we have created 4 objects of the employee class, and we will be adding this object to the list. Okay, and let's copy it. E2, E3, E4. Fine. And we need to sort it here. So before sorting, we will add a simple sysout statement so that we can see the objects in array list. So let's say it is a before sorting. List. Okay, make it in a new line. Okay, fine. Now we know that we have a ready-made sort method in collections, so we can use it. Collections.sort, and list goes here with, now we need this custom comparator object here, so we need to pass a comparator object here. So it will be new sort by ID, so that we have written a logic where we can sort employee objects by its ID. And again we will be printing, so let's print it here. Okay, now we will run. So I will press F11. Okay, so before sorting, you can see, let's, oh, I made a mistake. After, and add a new line here. I will run again. Okay, so you can see before sorting 101, 103, 104. We can see that array list is maintaining the insertion order, and after sorting it is 101, 102, 103, and then 104. So it is sorted. So we have sorted the employees using the custom comparator class. Okay, this is fine, and this is a normal implementation that we have to create a custom comparator class which should be implementing the comparator interface, and we need to write the logic for compare method in it. Now there is a better approach for that, and of course it is using Lambda expression. So how can we use Lambda expressions here? So basically, when we are using the Lambda expressions, we do not need that custom comparator class. We can simply write Lambda expression instead of it. So let's say, how can we do it? Collections.sort. We will be passing the list here, and now here, instead of passing the new custom comparator class, we will be passing the Lambda expression, and this Lambda expression will represent the implementation logic of compare method. So let's create one Lambda expression here, and I have told you how can we create Lambda expression for the methods. You can check this video. I will give the link in I button. So write, let's say eobj1, eobj2. Okay, these are the two input parameters that we are taking, and it gives eobj1.getId minus eobj2.getId. Basically, this logic is the same that we have written in the compare method, but we are simply adding it here in the Lambda expression. So we have written a Lambda expression for it, and now we can see that we have written a Lambda expression, and it represents the compare method from custom comparator class. Okay, we will save it, and we will clear the console, and we will run again. Press F11, and you can see the before sorting is the same, that array list maintains the insertion order, and in after sorting we are getting the sorted output. That means the Lambda expression is working perfectly fine here. And instead of creating a custom comparator class and passing its object, we can directly write a Lambda expression and we can sort the array list. So even if I deleted it from here, let's do it. Okay, and I will clear the console. I will run again. Okay, it is sorting. Till now we have covered what are Lambda expressions, what are functional interfaces, and how can we use functional interfaces to invoke the Lambda expressions. We have covered a few examples of it. Now in this video we will see what are the default methods in interface. Till Java 7, every single method in the interface is public abstract method. That means we can only declare method in interface. We cannot provide their definition in the interface. And every single class implementing that particular interface has to compulsorily provide the implementation for all the methods from that interface. Let's understand these 2 points in the Eclipse. So we will create a class. I will give it a name test. Let's add main method and let me create one interface here. So interface printable. Okay, and I will add one abstract method. So public void hello. Okay, and if my test class implements the printable interface, I have to compulsorily provide implementation for hello method. So you can see the compile time error here, and it says add unimplemented methods from the printable interface. When we hover on it and click the add unimplemented methods, you can see we need to provide implementation for hello method. So if we add multiple methods in the printable, we have to compulsorily provide implementation for all the methods. Let me try adding one more abstract method. So public void and print name. Okay, and I will save. Again you can see the compile time error. It says add the unimplemented method, and when we click on it, you can see we have to provide implementation for the print name method too. So as soon as we add new methods in the printable interface, we have to compulsorily provide implementation for all the methods in the test class. In real time, as the project improves, we add multiple features in the project, and as soon as a member of the team make changes in the any interface, he has to maintain all the code. He has to provide implementation for this method in all the classes that are implementing that particular interface, and this is really a tedious job. So is there any solution where we can provide directly a definition in the interface itself? Till Java 7 this is not possible, but as we discussed in Java 8, default method came to our help, and we can provide the concrete methods in the interface itself using the default methods. So let's see. In Java 1.8, along with abstract methods, we can also write concrete methods. These methods are the default methods. I will show you how can we declare default methods. Do not worry about it. And every single class implementing that particular interface has the freedom to provide its own custom implementation, or he can use the one which is default implementation provided in the interface. Let's see these topics in the Eclipse. So this is our printable interface and this is my test class. Okay, and the print name is a abstract method here. I want to make it a default. So let's comment it first and I will show you how can we add default methods to the interface. So we can write default void print name. Okay, and we can provide the definition here. I will simply add one sysout statement. Okay, so I have written one default method here and you can see I have provided this definition too. So now we will check this method first and then we will try how can we provide the custom implementation. So let me remove this and I will create a test object. Okay, t.print name. I will save and I will run it by pressing F11. Now this is the default implementation that we have provided in the interface itself, and also you can see that we have not provided the custom implementation in the test class yet till we are able to use the default implementation provided in the interface, and this is how the default method works. But now I want to provide my custom implementation. So what will I do? Similar to the hello method, I will override the print name method. So print name, I will override it and let's say I will add a sysout statement. Okay, now I will clear the console and I will run this program again. Okay, now you can see that we are printing the custom implementation and it is printing the RAM. So whenever we provide the custom implementation, it will use it, and if there is no custom implementation provided in that particular class, it will always use the default implementation. And this is how the default method work. Till now we have covered the Lambda expressions, the functional interfaces and default methods. Now in this video we will see what are the static methods. From Java 1.8 we can define static methods in the interfaces. Previously we have seen that we can use the static methods in classes and we don't have to create any object for using static methods, and that's why from Java 1.8 we can define the static method in the interfaces and we can use it directly. Static methods are generally used as a utility methods. So how can we define static methods inside the interfaces and how can we use it? Let's see it in the Eclipse. Okay, so I will create one class. Let's say test, and I will add the main method too. Okay, I will add an interface and let's say printable. I will add one static method here. So how can we add a static method? Public static void, and let's say I will give it a name print time. So I will be simply printing the current time, and I will add a sysout statement, new date. Let me import the date, Java util date. Okay, fine, save the code. Okay, now this is the test class and this is the main method of the test class. And how can we invoke the static method? So previously when we are using the static method in the classes, we will be giving class name dot and all the static methods are available to invoke. Similarly, here we will be using the interface name. And what is the interface name here? It is printable. So printable dot print name. Okay, save the code and we will run it. On successful execution, we should be seeing the timestamp in the console. So let's run it, and that's it. We can see the timestamp in the console, and that means we are using this print time static method. Now remember one thing, that my test class is not implementing printable interface. Now whether your class is implementing that particular interface or not, it doesn't matter here, because we are using the print time static method directly, and you can invoke print time method like this from anywhere in the code. We will be covering predefined functional interfaces. Now we have studied the concept of functional interface in previous video. What is functional interface? The interface which has only one abstract method. It can have multiple default methods, it can have multiple static methods, but it should have only one abstract method. That interface is called as a functional interface. And we know that functional interfaces are used to invoke the Lambda expressions. Now in Java 1.8, observing some day-to-day programming requirements, some predefined functional interfaces are provided, and these predefined functional interfaces are provided in java.util.function package. Now these four are the most important predefined functional interfaces. These are Predicate, Function, Consumer, and Supplier. Now these predefined functional interfaces are designed by considering commonly day-to-day programming practices and day-to-day programming requirements. In this particular video, we will see the Predicate predefined functional interface. Predicate is a boolean valued function. It returns boolean value based on some condition. So we will be providing a condition to the predicate, and it will do the conditional check and it will return the result, which will be boolean, either true or false. So let's say I want to check the age of student is greater than 20. So I will be providing the student object to the predicate. It will do the conditional check that whether the student age is greater than 20 or not. If it is greater than 20, it will return true, otherwise it will return false. Since predicate is a predefined functional interface, it should have only one abstract method, right? And it is test method. So it will have only one abstract method. It is a test method, and it will accept a parameter type t, and it will always return a boolean value. So we will see a simple example for predicate so that we will understand it better. So I will create one class. Let's give it a name test. I will add the main method, and here we will be trying a simple example for predicate. So I will be giving one number, and we have to check whether this number is greater than 20 or not. So I will write one predicate, and We have seen previously that functional interface is a type of Lambda expressions. So predicate is a functional interface and we can use it to invoke the Lambda expressions. So predicate P and I will write a Lambda expression here. Now if you are new to writing Lambda expressions, I have created a separate video for it. I will recommend you to watch this video before going ahead so that you will understand how can we write Lambda expressions for various methods. So here we want to check whether a given number is greater than 20 or not. So I will take an I as an parameter and then arrow, and I is greater than 20. Okay, that's it. So this is my Lambda expression for a predicate test method. So when we go to the predicate, let me open it. You can see it has a boolean test method, and so this parameter of type t, it is an integer for us and we are giving it as an I. Now this Lambda expression represents the test method of the predicate functional interface. So let me save it and sys out. So p dot test, which is a abstract method from predicate functional interface, and I will give value 15. Okay, I will save and now I will run it. Okay, it is printing false. That means the Lambda expressions is working fine. Now this is a simple example for predicate. Now again we will check for greater value. Let me run it again. Okay, now the parameter we are passing to the test method will be I, and it will check whether I is greater than 20 or not. Since 15 greater than 20 results false, we are seeing false on the console, and 25 greater than 20 is true, we can see the true on console. We will see one more example, and this time we will take a string and we will check whether this string contain a particular character or not. So let me create one class and I will give it a name test2, and main method. Okay, so I will write a predicate, and here it will be a string type because we will be expecting a string parameter. So p, and now I will write a Lambda expression for it. So let's say str is a string that we will be receiving, and we will check whether str contains, let's say, u. Okay, I will check whether the given string contains u or not, and let me write a sys out statement, and here we will pass p dot test and I will pass my name. Okay, so I will save it. Let me clear the console and I will run it, and you can see it has printed true. That means the string Gaurav contains u, which is correct. Now this Lambda expression represents the logic for test method, which is from predicate, and we are passing a string Gaurav. So it will check whether the string contains you or not. So let me try one more example, and now I will pass Mark. Okay, let me save it and I will run it again. Okay, now for Gaurav it is true and for Mark it is false, since Mark does not contain you. So we have seen two examples for predicate, and we know that predicate is a boolean function and it will return a boolean value for some conditions. So basically it will do a conditional check and it will return true or false based on the condition we have provided. In this video we will see the concept of predicate chaining. Now predicate chaining means combining multiple predicates into a single predicate. So let's say if I have a predicate which will check if the given number is greater than 5, and another one which will check if the given number is even. So if I want a number which should be greater than 5 as well as should be even, what should I do? I will combine these two predicates into one, and that's what the predicate chaining concept means. So basically we have three methods which will be used for predicate chaining. The first one is negate, the second one is add, and the third one is or. Now you may have studied the logical gates in your universities. This method represents the same concept. Now we will see the negate method. Negate means logical negation. So negate method will return a predicate that represents the logical negation of this predicate. Now this predicate in the sense, if I have a predicate P1 and if I have invoked the negate method on P1, the returning predicate will represent the logical negation of P1 as I have given in the example. So let's see its example in the Eclipse and you will understand it better. So let me create one class and I will give it a name test. Let me add the main method. Okay, so I will create one array, int array r, and let's take a number 1 to 10. Okay, and now I will add a predicate integer, let's say p1, and I will write a lambda expression here. So if you are facing any difficulty writing lambda expression, I will recommend you to check my first video. I will give the link in description or in I button. So we are getting parameter I, and let's say I gives I greater than 5. Okay, let me import the predicate by pressing Ctrl 1 and we will see the possible options. And let's import the predicate from java.util.function package. Save it. Okay, so we have a predicate p1 which will check if the given number is greater than 5. And let's create another predicate, same integer, give it a name p2, and now we want negation of p1. So p1 dot negate. Okay, and let's test this negation is working or not. So we will write a simple for loop for iterating over an array, and int I ar sys out. So I p2 dot test, I will pass I here. Okay, so let us check this for p1 also, so that we can compare both the results and it will help you understanding it better. Add a simple sys out statement. so that we can separate the results. Let's make it p1. Now it looks fine. Okay, fine. Okay, let me run it. So press F11. Okay, so we will check the result for v1 first. So what does our predicate v1 means? Check the given number is greater than 5 or not. So until 5 it says false, because 1, 2, 3, 4 and 5 is not greater than 5, and as soon as we go till 6 it says true. For all 6 to 10 it says true. Now this is normal predicate p1, and at p2 we have taken a logical negation of p1 dot negate, and when we invoke the test method on p2 it is giving opposite results. Now what our p1 means, if the number is greater than 5, and the logical negation of is the check if the given number is less than 5 or equal to 5. So you can check till 5 it is printing true, and after 5 it is printing false. So this is logical negation of the p1, and that's why you can see both the results are opposite. So this was the example for negate method. Let's check another method and we will see its example. Now we will see the AND method. AND method represents the logical AND operation. So it returns a predicate that represents a logical AND of this predicate and another one. So you can check in the example that p1 and p2. So it will return a predicate that represents the logical AND between p1 and p2. So there is a second point which will say, like, when evaluating the composed predicate, if this predicate is false then the other predicate is not evaluated. So if you have studied the AND operation, you know that if we need both the p1 and p2 as a true, if either of it is false the result will be false always. So the second statement says if the p1 is false there is no need to check the p2, because irrespective of p2's result, combined result will be false always. So let's see an example for it and you will understand it. So okay, we will modify this example only, and let me clear the console. Okay, so here we will create one predicate integer, and let's give it a name p3, and in predicate p1 we are checking if the given number is greater than 5. Here we will check if the given number is even. So I modulo operator 2 equal to 0. Okay, and we will create another predicate integer. Let's give it a name p4, and now here we will do the AND operation for p1 and p3. Okay, so we want a predicate which is a logical AND operation between p1 and p3. That means my number should be greater than 5 as well as it should be even, and let's iterate over it. So here we want p4 and we are passing the I, iterating over same array. Okay, so we do not want to see the results for this predicate, so I will comment it, and let me comment this also, and let's run it. Okay, you can check the result now. So what does our predicate p1 means? my number should be greater than 5. So until 5 you can see that it is false, because when we are doing the logical AND operation, if either is false, the combined result will be false always. So if P1 says, if check if the given number is greater than 5, until 5 we are getting false, so combined result is false. Now P1 and P3 says check if the given number is even, and we will be checking. So after 5 our first is true, that means 6 is greater than 5, and also 6 is a even number, and that's why we are getting the combined result as true. Now at 7 our first predicate is true, because 7 is greater than 5, but it is not a even number, so the predicate P3 is false, and logical operation between true and false is false, because either is false, the combined result will be false always. And that's why you can see for 8 the combined result is true because it is greater than 5 as well as even. For 9 it is false because greater than 5 but not even, and for 10 it is true. So this is an example for AND method. So let's see the remaining OR method. And so OR represent the logical OR operation. So AND method will return a predicate that represent the logical OR between this predicate and another one. So as I have shown you in the example, P1 or P2. So either predicate returns true, the result will be true. And the second point says, when evaluating the composed predicate, if this predicate is true, then the other predicate is not evaluated. Because when you studied the logical OR operation, you know that if the first one is true, then no need to check the another one, because irrespective of the P2, if P1 is true, the combined result will be true always. So let's check this example in the Eclipse and you will understand it better. So we have checked the negate and AND. So here we will check the OR method. Simply take this for loop here and we will create one predicate, integer, let's give it an MP5, and it will be OR between P1 or P3. Now what does P1 predicate is meant for? Checking if the given number is greater than 5 or not. Here you can say line number 11. And now what does P3 means? Checking if the given number is even or not. Line number 24. And P5 is the combined logical OR operation between P1 and P3. And here we will test it for P5. Okay, so we are passing I for P5. So let me comment out this. Okay, let me clear the console and we will run it a little more. F11. Okay, and you can see either is true, the combined result will be getting true. So if number is greater than 5, for number still 5, it is not true, but if a number is even, the combined result will be 2. So 2 is not greater than 5 but it is even, so the result is true. 3 is not greater than 5, also it is not even, so the result is false. Let's say for 6, it is even as well as it is greater than 5, so both are true, no issue, the combined result is true. For 7, it is greater than 5 and 7 is not an even number, but still it satisfies the one condition that it is greater than 5 and the combined result is 5. So for numbers greater than 5 it will be true always, because it always satisfies the first condition. For numbers less than 5 it satisfies the second condition for 2 and 4, and that's why you can see these results. So this was the example for logical OR operation. So hope you understood it, and if you have any questions you can ask it in the comments, no issue. In this video we will see the function. Now function is a predefined functional interface that accepts one argument and produces a result. Now we can compare function with predicate. We know that predicate is a boolean valued function. It always returns a boolean value, but in case of function it can return a result of any type. It can return a integer, a string, or a custom object. Now predicate has a single abstract method that was test, and function has a single abstract method apply. It accepts one parameter of type t and return a result of type r. Now t is the type of input parameter and r is the type of result of the function. So we will see one example in the Eclipse and it will help you to understand it. Okay, so I will create one class. Let's give it a name test. Add the main method. Okay, so we will be writing one function which will accept a string and it will provide a result as length of the string. So we will write one function from java.util.function package, and since our input parameter is string, we will write string here, and we are expecting length of the string in return, so result will be integer type. So integer goes here, and let's give it name fun. Now here we will be writing a lambda expression, and I have already created a video how can we write lambda expression for various cases. You can check this video. I will give the link in description. So what we are expecting here, it is string, and we will be producing result as length of the string. So str.length. Okay, fine. So let me write one sysout statement here, and we will be invoking the apply method of a function here. So fun.apply, and I will be passing a string parameter. So let's pass here code roles. Okay, save it and we will run it. So press F11. Yeah, it is printing length of the string that we have passed, and our function is working fine. Okay, so we will revise it. So basically we have created a function fun, and this lambda expression represents the logic of apply method, and in the sysout statement we are invoking the apply method using that functional interface fun, and we are passing a string code roles as an input parameter. Now this lambda expression will execute for the code roles, and that's why we can see 9 as printed on the console. Now this is one example, and we will take another one. So let me create one class test2. I will add the main method. Okay, so here I will be taking an integer array, and we will write a function that will find a square of each number from the array. so int array r, and I will take here numbers from 1 to 10. Okay, fine. So here we will write a function. So function from the java.util.function package. Now here our input parameter is integer, because we will be working on each element of the array, and it is integer because it is an int array, and we will be returning a square of that particular number. So square also integer. Okay, and give it a name fun. Here we will be writing a lambda expression. So we are expecting an integer gives, and we will be returning a square of that particular number. So I into I. Okay, yeah, our function is fine, and we will be simply iterating over the array. So let me write one simple for loop, int I AR. Okay, and simply print it. Okay, so here we will be invoking the apply method, and dot apply, and here we will pass the I, which is element of the array, and we will save it. Okay, let me clear the console and we will run it. Okay, so you can see, let me increase the size of console. Okay, so we have taken an array from 1 to 10, and we are printing square of each element of the array. So square of the 1 is 1, square of the 2 is 4, you can see here, square of the 3 is 9, and square of the 4 is 16 till 10, the square of the 10 is 100. We have printed. So this is the second example that we have written for function. Okay, so let me take one final example and we will wrap up this video. So let's give it a name test3, add the main method. Okay, and here we will be writing a function for it will accept a string and remove all the spaces from that particular string. So function java util function package, and here our input parameter is string, and in return we are expecting string only, but we will pass some string and our function will remove each space from that string and it will return a newly generated string. So return type also string, give it a name, and so we will be expecting a string, and how to replace each space from that string, we can use the replace all method of string. So str dot replace all, and here we will be replacing each space with an empty string. Okay, save it, and here we will be writing sysout, and I will invoke the apply method here. So here we will be passing my string with spaces. So let's say code roles. Okay, save it, clear the console, and now let's run it. Yeah, you can see that code roles is printed correctly here, and you can see our input string, it is with spaces, and we have printed it without spaces. and our function is working fine. Now basically this is the function, and we have written a lambda expression in it, and that particular lambda expression represent the implementation of apply method. In line number 11 we are simply invoking the apply method over fun, and we are passing a string with spaces, and as a result we are getting a string where all spaces are removed. So that was the final example for function. Hope you understood. Function is a predefined functional interface. It accepts one argument and produces the result of any type. In this video we will be saying function chaining. Now what does the function chaining means? It means combining multiple functions into single one. So let's say I have two functions. The first one will remove all the spaces from string, and the second one will make a string uppercase. So if I want to apply both the functions on my string, I will just combine it using function chaining concept. And there are two methods to do the function chaining. The first one is and then, and the second one is compose. So now we will see the and then method. It returns a compose function that first applies this function to the input and then applies the after function to the result. You can see the definition below. It is returning one function and it accepts one parameter after. And in the example I have given f1 and then f2. So first f1 will apply to the input and then f2 will be applied to the result of f1. The next method is compose method. It returns a compose function that first applies the before function to its input and then applies this function to the result. You can see the definition below. It is simply returning one function and it accepts one parameter before. Now in the example I have given f1 compose f2. Now here f2 will be applied to the input first, and then whatever result come, f1 will be applied to it. Now you will understand the difference between both the methods, right? There is a little difference between and then and compose, and it is just order reversal. So in and then f1 will be applied to the input first, and then whatever result come, f2 will be applied to it. In case of compose, f2 will be applied to the input first and then f1 will be applied to the result of f2. So we will see examples of it in Eclipse and you will understand it better. Okay, so I will create one class and I will give it a name test. Let me add main method. Okay, so we will see two examples. In first one the order will matter, and in the second one the order will not matter. We will use both the methods in both the examples so that you can compare these two examples and you will understand the difference between it. So let's see our first example. So here we will be taking one string as an input parameter, and our function f1 will remove the spaces from it, and function f2 will make it uppercase. So let's write our function. Import it from java.util.function package. Since we are expecting string, so be string, and the result will be string only. I will give it a name f1. Now here we will be writing lambda expression. So if you want to just revise how can we write lambda expression for various methods, I have created a video for it and I will give its link in the description or I button. You can just check it and you will come back to this step. So we will be getting str string as input parameter, and str gives str dot replace all, because we will be replacing all the spaces with empty string. Okay, our f1 looks fine. Now create another function and string only. I will give it a name f2, and now f2 will make a string uppercase. So str gives str dot to uppercase. There is a ready-made method which will make a string uppercase. Okay, now our f1 and f2 are ready. So we will take another function, and it will be a compose function of f1 and f2 using and then method. So let me write one comment here, and then. Okay, so the input will be string only, and here string, let's give it a name f3, and here f1 and then f2. Fine. Okay, let me add one simple sysout statement, and here we will invoke the apply method on f3 so that we can pass the input string, and we will be using the same string that we have used in the previous video. So okay, and here we will be writing our compose function for f1 and f2 using compose method. So I will write a comment here, compose, and create one function. It will be of string. I will give it a name f4, and f1 compose f2. Okay, save it. Add the similar sysout statement here, just make it f4. Okay, now we are ready to run. So let's see that we have taken two functions. The first one will remove all spaces, the second one will make string uppercase, and at line number 14 we have taken one function which is a composed function of f1 and f2 using and then method, and at line number 19 we have taken a composed function which is a composed function of f1 and f2 using compose method. Okay, and we are just printing the output by passing some input parameter. Here we have passed one string with spaces and it is in lowercase. So I will save it and we will run it. Okay, you can see the output is same. So for both the sysout statement, the output is same. But does order really matter here? Because either you will make a string uppercase first or you will remove spaces first, it doesn't matter. So whatever string you are passing, if you remove the spaces first and make it uppercase later, or make it uppercase first and remove the spaces later, it doesn't matter, and that's why we are seeing the output as the same. But when you are playing with numericals, the order matters, and we will see our next example where order really matters. So let me create one class. I will give it a name test2, add the main method. Okay, so here we will write two functions. The first function will take an input as a integer and it will produce as a result a square of that particular integer, and second function it will just add 2 in that particular integer. So let me write function. So here input will be integer type, and since we are getting result as a square, it will be integer type. I will give it a name f1, and here the lambda expression will be I gives I into I, because we want a result as square, right? f1 looks fine. Let's create a function 2. So integer again, integer, okay, give it a name f2, and here we will be simply adding 2 to the input parameter, I plus 2. Okay, now our f2 and f1 are ready. So here we will be creating a compose function using and then method. So function integer, again integer, let's give it a name f3, and here f1 and then f2. Okay, add the similar sysout statement, and we will invoke the apply method on f3 so that we can pass the input parameter, and we will be passing, let's say, 4. Okay, save it, and now here we will create a compose function using compose method. So function integer, and we will give it a name f4. Now it will be f1 compose f2. Okay, add the similar sysout statement below. Let's make it f4. Okay, now it looks fine. So let's say we have created 2 functions. The first one will return a square of the given integer, and second one will return a result as by just adding 2 in that particular integer. And then we are taking a compose function using and then method, and then we are taking a second compose for function which is f4 using compose method. So let me clear the console. We will first run and then I will explain the output to you. So run as Java application, and you can see the output is different. So first we will check it for f3. Okay, so as discussed in the theory part, when we are using and then method, the f1 will be applied to the input first, and then f2 will be applied to the result of f1. So what f1 says, it will produces the square of particular integer. So we are giving input parameter as 4, so square of 4 will be 16. And what does f2 says? It is simply adding 2 in the input parameter, and the result of f1 will be input parameter to f2. So 16 plus 2, and the output is 18. Okay, now this is for f3. In case of f4, as we have discussed in the theory part, when we are using the compose method, f2 will be applied to the input first, and then whatever result come, f1 will be applied to it. So f2 says I plus 2, So we are passing I as 4. So 4 plus 2, 6. And now 6 is a result of F2. Now F1 will be applied to the result, and I gives I into I. That means 6 is I here, and we will be getting square of it. So 6 into 6, 36. And that's the output. The first one is 18 and the second one is 36. So hope you understood. Just remember one thing, that and then and compose method have just one difference, and it is order reversal. So in case of and then, F1 will be applied to the input first, and then whatever result will come, F2 will be applied to it. In case of compose, F2 will be applied to the input first, and whatever result come, F1 will be applied to it. So just a order reversal difference. So as we have seen the first example where order does not matter, you can use anyone, it doesn't matter. But in case of numericals or any use cases where order matters, you should be precise using and then or compose for function chaining. Till now we have seen predicate and function. Predicate is a boolean valued function, and it will return boolean value based on some condition. And function accepts one argument, and it will return a result of any type. Now we will see the consumer. Consumer accepts one argument and it will return no result. That means it will not return anything. The single abstract method in consumer is accept. It will take one input parameter of type T, and the return type of accept is void. That means it will not return anything. So let's see a simple example in Eclipse. Okay, so let's create one class and give it a name test, add the main method. Okay, so here we will be taking one string and we are simply printing it on the console. So we will be writing a consumer for it. So consumer, import it from java.util.function package, and the input parameter will be of string type consumer C equal to, and here I will be writing a lambda expression. So str gives, and here we will be writing a simple sysout statement where we will be printing string str. Save it. Now our consumer is ready, and we can invoke the accept method on consumer where we can pass the input parameter string. So it will be code roles. Okay, save it, and now we can run it. So run as Java application, and you can see the code roles is printed on console. So basically this lambda expression represents the implementation of accept method, and as we have discussed, it will accept only one parameter of any type. Here we are passing a string, and it will not return anything. So basically we are just printing. Let's take another example where we will do some mathematical calculation. So test2 and take a main method in it. Okay, so here I will take one array, int array r, and let's take a number from 1 to 10. So here we will be writing a consumer, and it will take an integer as an input value, and it will print its square on the console. So let's take consumer, import it from java.util.function package. The input parameter will be integer type. Let's give it a name C, and the lambda expression here will be I gives, and basically we are printing on the console, so sys out I into I. Okay, so here I will write a simple for loop to iterate over an array. So int num AR, and here we will invoke the accept method on consumer. So c dot accept. So we are passing num here. That means we are passing each element of the array. Let's save it and run it. Run as Java application. You can see we are printing the square from 1 to 10. And this is how the consumer works. So basically consumer will accept one parameter of any type. It will process on it, but it will not return anything. Now we will see the consumer chaining. Consumer chaining means combining multiple consumer into a single one. So if I have multiple consumers and I want to apply them all on a single argument, I can do consumer chaining. There is only one method for consumer chaining, and it is and then. So let's check it. So basically and then method will return a consumer that perform operation, the first on this consumer and then the after one. So you can see the method definition below. So it is returning one consumer and it will accept an parameter after, which is a consumer. So you can see the example. So C1 and then C2. That means it will first execute the C1 for input and then it will execute the C2. So let's check an example for it in the Eclipse. So let me create one class. I will give it a name test, add the main method. Okay. So basically we will be passing an string which is message, and that needs to be logged and that need to be saved into DB. So basically we will create two consumers for it, and my first consumer will be, let's import it, consumer from java.util.function package, and it will take a string as an input. Let's give it a name C1, and here I will be receiving a string, so str gives, and I will simply print it. So basically we will be logging it. So let's say logging str. Okay, and I will write another consumer which will be saving in the DB. Basically we will just print statements here, and again it will be taking a string str gives and add another sysout statement. So these are the simple examples for understanding purpose only. So we have C1 and C2. We will create another consumer which will be a composed consumer of C1 and C2. So let's say consumer string only, and I will give it a name C3, and here we will do C1 and then C2. Okay, and here we can invoke the C3 dot accept method. So here we will be passing a simple message. So let's say simple message. Okay, save it, and now we will run it. So okay, so you can see the output. It is logging simple message and saved simple message in the DB. Basically these are just simple statement for understanding purpose. So consumer will accept one argument which can be any type. Here we are passing string, and it will basically consume it. It will not return anything. So let's run it again. Okay, you can see. Now we will see supplier. It represents supplier of results. That means it will not accept any argument, but it will always return a result, and that result can be any type. So it can be string, it can be object or integer. Supplier has only one abstract method, and it is get. So you can see it has a return type of T. So we will see a simple example for supplier. So let's move to the Eclipse. Here I will create one class, and I will give it a name test. Add the main method. Okay, now we will write one supplier which will give us a current time. So supplier from java.util.function package, and we are expecting date, so it will be a date type, and yes. Now here we will be writing a lambda expression. So it will not accept any argument, and that's why we are writing empty parentheses. Gives. Now here we will be returning new date. Okay, so import the date. Now press Ctrl 1, import from java.util package, save it. Okay, now our supplier is ready, and it has only one abstract method which is get. So we will invoke the get method. Also we want to print it, so I will write a simple sysout statement, and here we will invoke get. Okay, that's it. Save it, and we will run it. Okay, you can see the timestamp is printed. So this is the simple example for supplier. Supplier will not accept any argument, but it will always return a result. Now in this example we have written a supplier which will provide us date. So every time you invoke the get method, it will give us a new date. Let's check another example. I will give it a name test2, add the main method. Okay, now here we will write another supplier, and this time we will be providing a random integer. So here the type will be integer, yes, and it does not accept any argument, so empty parentheses, and it gives new random. Basically we want to generate a random integer, random, let's say. Okay, next int. Okay, till 1000. So it will generate a random integer till 1000. So let's add a sysout statement, and yes dot get, because get is the abstract method of supplier. Clear the console and run it. Okay, so each time I run the program I will get a random integer here. on console. And this is how the supplier works. Basically it will not accept any argument, but it will always return a result, and it can be any type. Now in the second example we are returning a integer. In the first one we have returned date. Now we will see two argument functional interfaces. Now both of the interfaces are very much similar, but there is only one difference, and we will check these differences one by one. So first we will cover the BiPredicate. Now in previous videos we have seen predicate. We know that predicate is a boolean valued function. It will return a boolean value based on some condition. Now BiPredicate is also a boolean valued function, but BiPredicate will take two arguments as an input. In case of predicate, we were just taking one argument as an input. So this is the basic difference between predicate and BiPredicate. In case of BiPredicate, we are taking two arguments. In case of predicate, we were taking only one argument. You can see the method signature here. It has abstract method test, and it is accepting two arguments, t and u. It is returning boolean value. So it will check the condition and it will return a boolean value. So we will check one simple example for BiPredicate and you will understand it better. So we will move to the Eclipse. Okay, so let me create one class. I will give it a name test, add the main method. Okay, so here we will be checking if the given number sum is greater than 5 or not. So in case of BiPredicate, we are taking two numbers as input. So we will be checking if their sum is greater than 5 or not. So let's say if you are taking num1 and num2 as an input, we need to check if the num1 plus num2 is greater than 5. So basically we will be writing a BiPredicate for this. So how can we write a BiPredicate? As similar to predicate, simply write BiPredicate, and here the type of input parameter will be integer. The type of second input parameter will be integer only. Okay, and we will give it a name p1, and here we will be writing a lambda expression. So here we will be taking two parameters as an input. So we need parentheses num1 num2 gives. Now what we have to check? If the num1 plus num2 is greater than 5. Simply we can copy paste it. Okay. Okay. Now this is a lambda expression for our BiPredicate, and it has similarly abstract method test. So we can invoke it. So I will simply write a sysout statement, and here we will invoke p1 dot test. So let's say I will pass the first argument as 5 and second argument as 6. Okay, save it and run this program. So run as a Java application, and you can see it is giving me true that 5 plus 6 is greater than 5, because that's why we have checked in the lambda expression. Now we will again pass two arguments. Now this time we will pass the less. So here I will take 1 and here I will take 3. Okay, and now I will run this program again. Press the F11. You can see it is printing true for the first sysout statement where 5 plus 6 is 11 and 11 greater than 5 is true. And here 1 plus 3 is 4 and 4 is greater than 5, false. So it is printing false. This is the example for BiPredicate, and as we have seen, it is very much similar to the predicate. The only difference is predicate will take one argument as an input. BiPredicate will take two arguments as an input. That's it. So we will save the next. That's it. So let's see the next two argument functional interface. The next two argument functional interface is BiFunction. We have seen in the previous video that function will take one argument and it will return a result. That result can be of any type. But what is the difference between function and BiFunction? The BiFunction will accept two arguments and produces a result. But in case of function, we were just accepting one argument. So you got the difference between BiFunction and function, right? In case of BiFunction, we will accept two arguments and produces a result. In case of function, we were just accepting one argument. It has the same abstract method apply, and you can see it is expecting two arguments. The first one is t and the second one is u, and also it is returning a result. That result can be of any type. It can be integer, it can be string, or any custom object. So let's take one example for BiFunction. Okay, so I will create one class here. I will give it a name test, add the main method. Okay, so here we will be adding two numbers and we will be returning its sum. So we will be taking num1 and num2 and we will be returning its sum. So we will write a BiFunction for it. So how can we write a BiFunction? Simply write BiFunction, import it from java.util.function package. Now here, what is the type of first parameter? It will be integer. What is the type of second parameter? It will be integer. And we are returning sum, and it will be type of integer only. So here I will give it a name f1, and here we will be writing a lambda expression for it. So since we are expecting two arguments, we need a parenthesis. Num1 num2 gives, now we will be returning a sum of num1 and num2. So num1 plus num2. That's it. Since it is a one statement, we do not need curly braces, we do not need return keyword. If you are facing any difficulties writing in lambda expressions, I will recommend you to check my first video, how can we write lambda expression for various cases, and that video will clear all your doubts. Okay, and now it has abstract method apply, and we can invoke that method. So simply I will write a sysout statement and I will invoke the apply method. Apply. So first argument will be 3, the second argument will be 6. Simply save it, clear the console. Okay, now we are ready to run this program and press F11 to run it. You can see the 9 is printed on the console. 3 plus 6 is 9. So this is a simple example for BiFunction. So we have written a BiFunction here, and we are invoking the apply method. So the basic difference between function and BiFunction is BiFunction will take 2 arguments as an input and it will provide the result. The word by specifies the 2 here. Okay, so we will see the last 2 argument functional interface, and it is BiConsumer. Similar to predicate and function, we have also covered consumer in the previous videos. We have seen that it represents an operation that accepts one argument and it will not provide any result. But what is BiConsumer then? It will accept 2 arguments and it will not provide any result. It has the same abstract method except. You can see the method signature here. The except is accepting 2 arguments t and u, and the return type of exec method is void. That means it will not return anything. So you got the difference. The consumer will accept 1 argument and it will not return any result. The BiConsumer will accept 2 arguments and it will not provide any results. So the only difference is in number of arguments. Consumer will accept 1. The word by specifies 2. That means it will accept 2 arguments and it will not return anything. So let's take one example for BiConsumer. So I will create one class here, give it a name test, add the main method. Okay, so here we will print the name of the student and marks he got. So we will printing name and marks. So how can we write a BiConsumer for it? So let's say BiConsumer, import it from java.util.function package, and the type of first parameter will be string. The type of second parameter will be integer because we will be passing marks as a second parameter. C1, and here we will be writing a lambda expression. So here we will be writing a lambda expression. Since we are taking 2 parameters as an input, we need a parenthesis. So I will take it below so that you can see it clearly. And here I will be writing name and marks. Okay, it gives. So we will simply write a printout statement here, sys out, and we will write here the first one will be name got. Now here it will be marks and marks. Okay, so name will go here and marks will go here. Save it, and it has the same abstract method except, so we can invoke that particular except method. So I will write c1 dot accept, and here I will pass Ruby got 85 marks. So you can see the first parameter is a string, and that's why we have written a string here. The second parameter is integer, we have written an integer here. Okay, save it, clear the console so that clear the previous outputs, and run this program. Run a Java application, and you can see Ruby got 85 marks. So we have written a BiConsumer. Now consumer is, it will take 1 argument and consume it. That means it will not provide any result. In case of BiConsumer, it will take 2 arguments and consume it. That means it will print it or it will save in the DB. So it can do any operation, but it will not return any result. So we have written a BiConsumer which will simply print name and marks, and we have invoked the accept method which says Ruby got 85 marks. Now I can pass another parameters here, and here we will write James got 53 marks and save it. Run as a Java application, and you can see Ruby got 85 marks, James got 53 marks. Okay, so this is a simple example for BiConsumer. So we have seen the two argument functional interfaces. The first one was predicate, that means it will take two arguments and it will return a boolean value. The second one is BiFunction, that means it will take two arguments and it will return a result. That result can be of any type. And the third one is BiConsumer, that means it will take two arguments and it will not return any result. The return type is void. And we have covered the simple examples for all these two argument functional interfaces. This is really simple concept. Just there are chances that you will receive two arguments sometimes. So instead of using predicate, you can use the BiPredicate and so on. So whenever you are getting two arguments, you can use two argument functional interfaces. And there will be no two argument functional interface for Supplier, because as we know, Supplier do not accept any argument. It simply return result. So we have seen Supplier predefined functional interface. It will not accept any argument. It will simply return a result. Since it is not accepting any argument, there is no chance of BiSupplier. Now we will see method reference using double colon operator. In Java, double colon operator is used for method reference and constructor reference. In this particular video, we will see method reference. As discussed, we have seen functional interfaces, and we know that functional interface should have only one abstract method. Now, to write the implementation logic of that particular abstract method, we have written many Lambda expressions. Sometimes the Lambda expression does nothing but call an existing method, or sometimes the Lambda expression may have the same logic which is already present in an existing method. In that particular cases, instead of writing a separate Lambda expression, we can simply refer to the existing method using double colon operator, and this is all about the method reference concept. Basically, method reference will enable you to refer to the existing method by name, and when we will see the example, you will get to know that it is really compact, easy to read, and we will reuse the code. A class can have static methods and instance methods. So how can we do method reference for static methods and instance methods? So let's see syntax for static method. So usually when we call static methods on the class, we will use class name dot static method. But in method reference, we can use it like containing class. This will be the class name which contains this method, and here the static method name goes. Now to call the instance method, we have a similar syntax. Instead of class name, how can we call the instance method? By creating object. We should have an object of that particular class, and we can invoke the instance method on that particular object. And similarly, for method reference, we should have a object name here, and the instance method name goes here. So this is a very simple syntax for static method reference and instance method reference. So we will see a simple example for both the method references and you will get it. So let's move to the Eclipse. Okay, so we will create one class. I will give it a name test, add the main method. Now here we will be adding one functional interface. Let's say printable, and it should have only one abstract method. Let's add it, public void hello. Okay, so how can we write implementation logic for hello method? We can use the Lambda expression. So let's say printable p1, it is not accepting any argument, so we will use the empty parenthesis here. It gives a simple sysout statement. Okay, so we will invoke the hello method using p1 dot hello. Save it and we will run it. You can see the hello world is printed on the console. Now this is fine, we have used the Lambda expressions, but let's say I have one static method and it will be public static void print hello, and it will not accept any argument and it will have simply one sysout statement. So okay, so this is my static method from the class. Now instead of writing a Lambda expression, how can we use the static method reference? We will see below. So printable p2. So here I don't want to write my separate logic using Lambda expression. Here I want to reuse the logic from print hello static method, and we can do it using static method reference concept. So what is the syntax for it? Here the class which has that particular static method, print hello static method, is present in the test class. So test class will go here. Now double colon operator and then name of the static method, print hello. That's it, and add the semicolon. Remember one thing, that you should not add parenthesis here. It should have only static method name. And now you can invoke the hello method using p2. That's it. Save it, clear the console and run it. You can press F11. Now you can see the line number 13 hello invocation prints hello world. The line number 16 hello method prints hello world from static method, because we are using static method reference concept here. Now let's say my test class has one instance method. I will create it, public void hello2. This method also do not accept any argument and it has also a similar sysout statement. Instead of static we will write instance here. Fine. Now this is my test class. This has one static method, it has one instance method. Now instead of writing my separate logic for hello method using Lambda expression, I will reuse the instance method logic. How can we do it? Using instance method reference concept. So here printable p3. Now what is the syntax for instance method reference logic? We should have one object of that particular class. So print hello2 is present in the test class. So let's create one test object. Test t equal to new test. That's it. Now we have a test object, and here goes object name t, double colon operator, and here goes the instance method name. What is the instance method name? Print hello2. You can paste it here and simply add the semicolon. Now we can invoke the hello method using p3. Save it. Okay, so I will clear the console and let's run it again. Yeah, you can see the third pre3.hello is printing hello world from instance method. So this is the simple example for method reference concept. So let's revise this example one time. So in line number 12 and 13, I have used the lambda expression to write the implementation logic for hello method, and it is a simple sysout statement hello world. But if I want to reuse the logic from existing methods, it may be static or instance, I can use it using method reference concept. So at line number 15 and 16, we have used the static method reference concept because print hello is a static method. So the class name will go here, double colon operator, and static method name. Now at line number 19 and 20, we have used object method reference concept. Now for that we should have an object of the class, and my instance method is print hello2. So print hello2 is present in the test class. I have created one test object here, and now test object name goes here and the instance method name goes after double colon operator. And now we can invoke the hello method. This is how we have used the object method reference and the static method reference. And now we will see how can we refer to the constructor. So the syntax for constructor reference is class name, double colon operator, and new keyword. We have covered in the previous video, if we are referring to the static method, class name will go here, double colon operator, and static method name will go here. And when we are referring to the instance method, object name will go here, double colon operator, and instance method name will go here. But now since we are referring to the constructor, class name, double colon operator, and new keyword will go here. So let's see a simple example for it and you will understand it better. So let's move to the Eclipse. Okay, so we will create one class. I will give it a name test, add the main method. Okay, so first we will try to write a lambda expression and we will try to get the object by using lambda expression, and then we will see how can we convert it into constructor reference. So first let me create one functional interface here. Let's say interface printable, and add the one abstract method here which will be public. So basically we need to get the object, so we should have one class. So let's say it will be print class. Okay, P should be capital. Okay, and the method should be get, which will not accept any parameter. Okay, now we should have a print class. So let's create this print class. Okay, and I will add a no or constructor here. So let's say public print class. It should not accept any argument, and we will add a simple sysout statement. Okay, so I will save it. So we have a functional interface which has abstract method get, and we have a class which is print class, and it has no org constructor in it. Now this is our test class, and we are in the main method of the test class. So how can we get the object of print class? By using functional interface printable. So I will write printable p1, and here we will be writing a lambda expression. So this is the abstract method of printable, and we will be writing a lambda expression for it. Since get is not accepting any argument, it will have empty parentheses. And what it gives? So it gives a print class object in return. So it will give new print class. Okay, so our lambda expression is ready, and we can invoke the get method. So let's say p1.get. Save it and run it. Press the F11. Okay, you can see using no org constructor. So it is our functional interface. This is the class, and in test class main method we have written a lambda expression which represent the implementation of get method. So this is fine. We have used the lambda expression, but can we use the constructor reference here? Since the print class has one constructor, we can directly refer to it. So let's say printable p2, and here I will be referring to a constructor of print class. So print class will go here. Now double colon operator and new keyword. That's it. Here we will invoke the get method. Save it, clear the console, and again run it. Press the F11. You can see it is printing two times. The line number 20 is printing the first line. Line number 23 is printing the second line. You can see the difference now. In first case, we have used the lambda expression, which is logical implementation of the get abstract method. And in the second case, instead of writing a implementation for get method, we have directly referred to the constructor of print class. And how can we refer to the constructor of any class? The first class name will go here, then double colon operator, and then new keyword will go here. And finally we can invoke the get method, which will use the constructor. So this is the simple example for constructor reference. Now we will check some important points about the method reference and constructor reference. Whenever you are referring to a method, you should check that the method you are referring to has the same arguments. And the second point is about constructor reference is that we should use the new keyword. We have checked in case of method reference, we are giving the static method name or instance method name, but in constructor reference we have to always use the new keyword. Today we will see one of the most important topic in Java 8, and it is Java 8 Streams API. We will see what are streams, how can we create various streams, and what are the different methods that we can use with streams. We will see their respective examples too. So let's discuss what is the stream first. Now we know that group of the objects as a single entity is called as collection, and if we want to process that collection, we can use Stream API. But what is the meaning of streams then? A sequence of elements from a source that supports data processing operation can be called as a stream. Now we will elaborate this definition. a sequence of elements means Java Streams API will provide an interface over a collection where we can access elements in sequence from a source. Now what does the source mean? That sequence of element is coming from some source, right? So it should be a collection, it should be an array that support data processing operation. Data processing operations means what? Filtering, mapping, updating. These types of operations are data processing operation. From this definition we will understand that strings is a sequence of elements from a source that supports data processing operations. Let's see some simple example where we will see how can we process collections without using stream and stream, so that you will understand the basic difference. So let's move to the Eclipse. Okay, here I will create one class and give it a name test. Add the main method. Okay, so here we will take one example. So we will take a list, let's say array list of integer, and we will take some numbers from 1 to 10, and we have to get another list which contains only number greater than 5. So we will have one AL of integer, and we should have one AL2 of int greater than 5. Okay, so this is our task. We will see how can we create it without using stream and then with stream. Okay, so let's create one list of integer, and I will give it name AL, and here goes arrays dot as list. Okay, so you can create list AL equal to new array list and then add numbers, but just use this shortcut here. So here I will add number from 1 to 10. Okay, let's import the list. Press Ctrl 1 and import this. Okay, save it. Okay, so we have AL with us, and our task is to create AL2 where integer should be greater than 5. So we need to collect all the integers which are greater than 5. Okay, so let's create an empty array list first. List of integer AL2. Now here we will create an empty array list. Okay, and we will see how can we do it without using stream. So let's say case 1, without using stream. Okay, and how can we do it? So basically we will iterate over that list, and we will write a simple if condition. If the element is greater than 5, we will add it into AL2, otherwise we will move forward. So let's iterate over the AL. How can we iterate? Writing simple for loop. So let's iterate integer, and it will be I from AL. Okay, this is a simple for each loop, and here we will write a condition. If I is greater than 5, then add it to the AL2, otherwise do nothing. Okay, now simply add a sysout statement so that we should know what is AL and what is AL2. Sysout, here we print AL, and here we will add AL2 without using streams. Okay, and make it AL2 here. Save it, and now we will run this program to check whether the without using streams case is working fine or not. So let's run it using press F11. Now you can see this is the AL which contain numbers from 1 to 10 and we are collecting numbers greater than 5. Okay, this is fine. That means we have an array list and we are filtering out numbers which are greater than 5. So this is without using streams, but since Java 8 we have streams API and streams API can be used to process over collections, and this is a better way to do this task. So let's check. I will give it a name case 2 and like with streams API. Okay, so how can we do it? We can simply write AL2 here because our streams will return a array list, and we will be getting stream of AL dot stream. In this way we will get a stream, and what we are doing, we are filtering out. So there is a method called filter which can be used, and this filter method will accept a predicate. Now predicate is checked for boolean condition, so it will return a boolean value. Now here we will be writing a lambda expression. If you don't know how can we write a lambda expression, or if you are confused about the predicate, I will give the link in description. You can check both the videos. So here we will be writing I huge I should be greater than 5, and then we will collect it using collector. So collect, and here collectors, let's say collectors to list. Okay, just add the semicolon and save it. This is the Java stream. This is using Java 8 streams API. Now we will understand this statement. So first we get the stream on our AL array list, and then we have filtered the elements where I is greater than 5. Now here I is a input parameter which will be an element from the AL, and we are checking whether our element is greater than 5 or not. If it is, then collect it to the list. Now we will understand all the specific methods in coming videos, so do not worry about it for now. Just understand the concept that how can we use streams, and this whole process we are collecting into a stream using collect method, and we are getting AL2. So here we will be simply adding a sysout statement of AL2. Okay, so we have checked the first part, running it. Now we will just comment out the first part and we will check the second part only. So I have commented out the first part, and here we will be using streams. Okay, so I will save it. I will clear the console and then run it as a Java application. Or press F11. You can see we are using streams. This is an array list where we have numbers from 1 to 10, and we are filtering out numbers which are greater than 5. So you can see here that in case 1 we are using a for loop, and then we are writing some if condition, and then we are adding to the array list, and this is a sysout statement. In second condition we are doing it in a single line. So you can see the difference, and you can see stream will reduce the length of the code. We are just doing all the things in just one simple statement. So this is the basic example for streams, and as we have seen, stream is a sequence of elements from a source and that can perform data processing operations. Now here we are filtering it out. Now when we are talking about operations, there are two types of operation, and in this particular video we will check these two types of operation. The first one is intermediate operation and the second one is terminal operation. So we will check one by one what is the intermediate operations and what is the terminal operations. So first we will check the intermediate operation. Now what does it mean by intermediate operation? The word intermediate suggests that it is in between. So whenever we are getting a streams of a collection, the intermediate operation will always return a stream object only. So let's move to the example and I will tell you. Okay, so this is an example that we have written in previous video, and here we are getting a al.stream. So this part will return a stream object. Okay, so this is the example that we have written in the previous video, and you can see al.stream, and then we have added a filter operation. Now, and when we check the filter operation, you can see it will be returning a new stream. So it will returning a stream, and then again we can add another operation in front of it. So as per our presentation slide, the intermediate operation are the operation which always return a stream object. It allows the operation to be connected to form a query. So like we have added a filter operation, then again we can add a map operation or many other operations we can write and it will form a query. So basically intermediate operations will allow us to do so. It does not perform any operation until the terminal operation is invoked. Now for now, just read the third statement and just do not worry about it. I will tell you this later. Okay, so this is an intermediate operation. So let's move to the example once again and we will see the intermediate operations there. Okay, so this is the example. Now al.stream and then filter operation. Now this is an intermediate operation because it is returning a stream. Now if I want to add any other operations here, I can easily add. And about this third point we will discuss once we will see the terminal operation also. The examples for the intermediate operations are filter, map, limit, sorted. Do not worry about these methods. We will see all the methods and their respective examples in the upcoming videos. So this is the intermediate operations. Let's see the terminal operation now. So we have seen the intermediate operation. Now we are seeing the terminal operation, and that word terminal means which will be a ending operation. So it returns a result from the stream. So basically terminal operation will return a result from the stream, and the result can be integer, an object, or a string. It can be anything. And the example for the terminal operations are collect, count, get. These methods are the example for terminal operation. Okay, so let's move to the example once again. Okay, so filter is an intermediate operation because it is returning a new string, but collect is the terminal operation. It is returning the result of the reduction. You can see it here, because what does this statement means? al.stream means we want a stream and then we want to filter out all the elements, and this is the condition that we have passed. Like if the element is greater than 5, then collect it to the list. We are using collectors.toList as a parameter to the collect method, and it is collecting all the elements which are greater than 5. So here filter is an intermediate operation. It is doing the task, and collect is the terminal operation. It is collecting all the elements. We cannot add any more operation ahead of the collect because it is a terminal operation, and the operations query will end here. If you want to add some operations after filter, you can easily add like map or any other operation, map to double, map to int. You can see the various operations here. And we have discussed about the third statement, that intermediate operation will not do any task until and unless the terminal operation invoked. That means whenever this query executes and it says that we have to collect numbers, then it will check which number we have to collect, and it will say all the numbers which are greater than 5. So first terminal operation will execute or invoke, and then the filter operation, which is an intermediate operation, invoked. So even if you are not confident about this concept, so do not worry about it. We will check this concept in detail. We will check a specific example for it in the upcoming videos where we are checking various examples. So for now, you should understand only two things, that intermediate operations are the operations which return a stream, so that we can add another operation in front of it. The examples are like filter, map, limit, or sorted. Okay, and the terminal operations are, it will provide a result, it will not return any stream. So terminal, this is because these operations will end the operations query, and it provides the result. That result can be anything like integer, string, or object. And the example for terminal operations are collect, count, get. This type of methods are example for terminal operations. Now we have seen these two type of operations, and we will see the specific example for this type of operations in upcoming videos. From this video onward, we will see some Stream API methods which are used to perform these operations. And the first one is filter method. So filter method will return a string consisting of the elements of this string that matches the given predicate. If you can see the third point, which is a method signature, here filter method will accept a predicate. Now predicate is a boolean valued function, and it returns a boolean value based on some condition. Now we have created a separate video on predicate predefined functional interface. If you want to check it, I have given the link in the description or I button. And you can see the predicate is returning a string. Now it will return a string of only elements which matches the given predicate. So let's say if I have an array list of numbers and I'm adding a predicate which will check if the given number is greater than 5 or not. So it will return a stream of only elements which are greater than 5. So let's see a simple example of the filter method in Eclipse, and you will understand it better. Okay, so we will be creating one class, give it a name test, add the main method. Okay, so here we will be taking list of integers, let's say from 1 to 10, and we will be collecting all the numbers which are even in the another array list. So let's take one list of integers, and I will give it a name list, and let's say arrays dot adds list, and here I will be adding numbers from 1 to 10. Okay, so let's import the list and press Ctrl 1, enter. Okay, so we have a list of integers from 1 to 10. Now we need to collect all the integers which are even, and in this particular example we will try the two cases. In first case we will be not using the streams API, and In second case, we will be using the streams API so that you can compare both the cases and you will see the difference. How can stream help us to reduce the length of the code and makes it more readable, maintainable. So let's go with the case 1 first. So how can we collect all the integers which are even? First, we need to iterate over the list, and then we will be checking if the integer is even or not. If it is even, we will be adding it to the another array list. So let me create one list first, list of integer, and give it a name list2 and say new array list. Okay, it is an empty list2, and to iterate over the list we will be writing a simple for each loop. So here goes integer I on list, and here we will be writing a simple if statement. So if the number is even, and how can we check if the given number is even or not? Using modulo operator. So let's say I modulo 2 equals to 0, then it is an even number, and if it is an even number we will be adding it to the list2. That's it. Okay, so let's add some sysout statement so that we can confirm our functionality is working fine. So I will add a sysout statement here. Also we will add the sysout statement here too, so that we can print the original list and then the output. Okay, so this is fine. Just run it by pressing F11. Okay, you can see the output. It is a list which is our list of integers from 1 to 10, and in list 2 we are collecting all the numbers which are even. So the case 1 without using streams is working fine, and now here we will be checking case 2, and case 2 is using stream. So okay, so let's create another list of integer, and I will give it a name list3 new array list. Okay, and we will be writing a string here. So let's say list3. Now we need to get the stream of list dot stream using stream method, and which operation we need to perform? Filter accepts a predicate. Now what is predicate and how can we use it? I have created a separate video on the predicate. You can check it. I will give the link in the description. So here we will be writing a predicate using Lambda expression. So let's say I gives I modulo 2 equals to 0. That means we are checking if the given input parameter I is even or not, and then we will be collecting it using a terminal operation collect. Let's say collectors to list. Okay, add the semicolon and it is fine. So just add simple sysout statement here to list3. Okay, so our case 2 also ready, and we will clear the console. Okay, and run it again by pressing F11. Okay, let's make the console a little bigger. Okay, so this is the list which is having numbers from 1 to 10, And in list 2 we have collected even numbers without using the stream API. And in list 3 we have collected the even numbers using stream API. So you can see streams will help us to reduce the code length, and also it will help us to make code more readable and maintainable. You can see the case 1 where we are writing for loop and if statement, and then we are externally iterating over the array list to check the condition. But in case of the streams, it is internally iterated over the collection and the filter operation is processing. It is efficient and a better way to do the same task. Now we will see the map method. The map method will return a stream consisting of the results of applying the given function to the elements of this stream. That means a map method will accept a function and it will apply this particular function on all the elements of the stream, and it will return a stream of updated elements. You can check the third point, which is a method signature for map, and it says it is accepting a function mapper. Now function is a predefined functional interface. It will accept a parameter and return a result. That result can be of any type. Now I have created a separate video on function. I have given the link in the description. You can check it. The function mapper will apply to all the elements of the original stream, and a stream of the updated elements is returned. And this is an intermediate operation. So let's check a simple example for the map and we will understand it better. So let's move to the Eclipse. Here I will create one class. I will give it a name test and add the main method. So here we will be taking a list of numbers from 1 to 10, and we want a new list where all the square of the numbers are present. So let's say I am taking a list here, list integer, and I will give it a name list. Here let's say arrays as list, and here I will be adding numbers from 1 to 10. Okay, so let's import the list. Press Ctrl 1. Fine. Now we have the list of numbers 1 to 10, and now here we will be getting a new list which contains square of all the numbers. And how can we do it? As seen in the previous method, here too we will go with the two cases. In our first case we will be not using the streams API, and in the second case we will be using the streams API, so that you can compare both the cases and you will see the difference yourself. So let's say without using streams first, how can we get a new list of squares of all the number? So let's iterate over the list and make a square of each element and add it to the list 2. So basically we will need a new array list. So let's say list of integer. I will give it a name list 2. Okay, new array list, and let's write a simple foreach loop to iterate over the list. Okay, and here we will be adding square to the list 2. So let's say list 2 dot add, and we will be adding square, so I into I. Okay, and let's add a simple sysout statement so that we can check the functionality. Also add the sysout statement above so that we can print the original list. Okay, so this is the list of numbers and we have printed it, and we are adding square to the list 2 and we are printing list 2. So let's save it and run this by pressing F11. Okay, You can see the list of numbers here, and we are getting a list 2 where all the squares are present. 1 square is equal to 1, 2 square is 4, 3 square is 9. So until 10 square is 100. And this is how we get the squares without using the streams API. Now we will see our case 2 and we will see how can we get it using the map method. Okay, so I will create a new array list, integer. Okay, and here we will be writing a stream. So we want to get a stream over list dot string. Okay, so we will be getting a stream using dot stream method, and then we want to perform some operation. So for each element we want to multiply it by itself so that we can get its square. So this operation can be done using map method, and map is accepting function. So what will be the function here? We will be writing a lambda expression for it. So let's say I gives I into I. So for each input parameter we are multiplying it by itself, and we need to collect it using terminal operation, and it will be a collect method. Collect collectors dot toList. That's it, at the same column. Fine. Okay, so we will be adding a sysout statement here too. Let's make it a list 3 and using streams API map method list 3. Save it, clear the console and run it. Okay, so this is the list of numbers, and here we are getting all the squares without using streams API, and here we are getting list 3 which are squares of the numbers using stream API map method. So you can check the example. Here we are writing a for loop and then adding it and then adding a square. So here we are iterating over the list externally, and in case of streams we are getting the streams over list and then we are performing the map operation. So while performing the map operation, the iteration is happening internally and it is an efficient way to perform the task. And finally we are collecting it using terminal operation collector. Limit method will return a string consisting of the element of the string truncated to be no longer than max size in the length. Now what is the max size? It is a long that we pass as a parameter to the limit. If you can see the third point, the method signature is given. Limit will accept a long max size and it will return a string of the elements till max size. That means if I have an integer of 1 to 10 and I have passed max size as 5, it will return a stream of 5 elements. So let's see a simple example and we will understand it better. Okay, so here I will create a class. So let's say list of integer list and as list. Here I will be adding numbers from 1 to 10. Okay, import it by pressing Ctrl 1 and press enter. Okay, so we have a list which has numbers 1 to 10. Now I want another list which will have numbers from 1 to 5. And how can I get it? I will get it using the limit operation of streams. So first I should have an empty array list. So let's create a list of integers and give it a name list 2 Okay, so I will get a stream on list, so list dot stream. Okay, and then I have to perform limit operation. I will add limit, and here I will add 5. Now we have a stream, we have performed the limit operation, so that we are limiting the elements till 5, but we need to collect these elements in list, and so that we will take another terminal operation, collect collectors to list. You can collect it in an array too. In that case you have to choose the to array option. Okay, save it, and you will have the list 2. So simply add the sysout statement so that we can check the output. Add it here too. Okay, I will save it, and let's run it as a Java application. Okay, so we have a list of numbers from 1 to 10, and by performing the limit operation we can get the list of 1 to 5. We are passing 5 as a parameter to limit, and if you pass the 6 as a parameter we will get numbers from 1 to 6. So this is the limit operation, and this is how it works. We have seen filter method, map method, and limit method. Now we will see one another method, which is sorted method. If you want to sort elements of the array or list, you can use the sorted method of stream. Now there are two types of sorted method in the streams. The first one is sorted, and the second one is sorted, which accepts a parameter comparator object. Now sorted method can be used which do not accept any parameter in case of natural sorting order. If you want to sort your elements in natural sorting order, you can go with the first method, which is sorted. But if you want to sort your elements in customized sorted order, then you can use the comparator to create your customized sorting logic, and you can pass this comparator object as a parameter to the sorted method, and you can sort your elements in customized sorting order. So we will see both the methods. We will go one by one, and let's see the first method, sorted method, which do not accept any parameter. And in case of the first method, we will be sorting our elements in natural sorting order. The sorted method, which do not accept any parameter, it returns a stream consisting of the element of this stream sorted according to the natural order. Now this is the important part. It will always sort elements in natural sorting order. It may throw class cast exception if the element of the stream is not comparable. We will see this point in example. Do not worry about it. Just remember that your element of the stream should be comparable. If it is not comparable, it will throw the class cast exception. And this is an intermediate operation. It means the sorted method will always return a stream, and that's why it is an intermediate operation. And this is a simple method signature. So let's see one simple example for the sorted method in Eclipse, and we will understand it better. Okay, so let's create one class test and add the main method. Okay, so here we will be creating one simple list of elements which will be integer, and we will add 1 to 10 numbers and we will sort it. So let me create one list of integer. Let's say list and we will be adding arrays as list. So here I will add 1 to 10 numbers in not sorted order, that means in random order, so that we can prove that we will be sorting these numbers using sorted method of the stream. So here I will add 1 to 10 numbers. Okay, so let's import the list. Click on the list and press Ctrl+1 to see all the suggestions, and you can see import list from java.util package. Just press enter and okay, now error is resolved. So we have a list. Let's add a simple sysout statement so that we can simply print that list. Okay, and now I want to sort these numbers using the stream. So let's create a stream of the list. So list.stream. Now we have a stream and we can sort it. So using sorted method, you can see there are two options here. The first one is which do not accept any parameter, and we will select this one so that we can sort using natural sorting order. And this is an intermediate operation, so it will return a stream, and to collect it in a list or array we will be using a collect method, which is a terminal operation. So let's collect it in list. So collectors to list. Okay, yeah, add the semicolon, and we will be collecting it in a list. So let's create one list here, list of integer, and let's say it is a list 2. Okay, add this sysout statement so that we can see the sorted list. Add a new line here and it will be list 2. Okay, save it. And now I will run the program. So run as Java application. Okay, you can see the list 1, which is in random order, as we have added in the list. It is list 1, and you can see the output here. It is in sorted order, and which is list 2. Let's add a 2 here, save it. Okay, so this is a list 1 and it is a list 2. So it is in a random order as we have added in the list, and it is in sorted order. So we have used the sorted method to sort the elements of the stream in natural sorting order. We have seen a simple example for sorted method, but the second point we have discussed earlier is if the elements of the streams are not comparable, it will throw the class cast exception. We need to check this point. So we will see one more example where we will get the class cast exception where our elements are not comparable, and we will see how can we resolve it. So let's move to the Eclipse again. Okay, here I will create one more class and I will give it a name test2 and add the main method. Okay, so here I will be creating a list of custom class. The custom class is employee class, which we have created earlier in our previous videos. So to be precise, it is present in Lambda expressions in collections. So this is an employee class. So do not worry about this class. It is a simple class with two variables, integer ID and string name. We have added a simple constructor which is a constructor with parameters and setters and getters methods for all the variables, which is id and then name. And at last we have added a toString method so that we can print the employee class. This is the class which is used in the previous examples, and if you want to just see it, you can simply refer to the GitHub repository link that I have given in the description. So do not worry about this class. This is a simple custom class named employee, which has two variables and its respective constructor, getters and setter, and toString method. That's it. Okay, so we will come to our test2 class. So here I will create a list of employee. Okay, I will give it a name list, and first we will import it. The list Ctrl+1 to see the suggestions, and import list from java.util. Enter. Okay, now we need to import the employee class because it is present in some other package, and Ctrl+1 import employee from other package, which is our previous example package. Okay, now here arrays dot as list, and here we will be creating employees. So let's say new employee, and since we have added the constructor, it is giving us an option integer id and string name. So id will be 101 and name will be Shubham. Okay, let's create another one. I will simply copy it. Okay, and give it a name. Okay, and id should be 3. We are giving it in a random order so that we can prove that we will be able to sort it. Okay, now we have a list of employees ready with us, and we will be sorting it so that I want to print my list according to the ID. So the Shubham will be printed first because it has 101, and then John will be printed because it has ID 102. So this is the simple list, and now we will be applying the sorted method so that we want to print all the elements in natural sorting order of their ID. So let's get a stream. So list.stream. So we have a stream now, and apply the sorted method. Sorted method we will be using the first one because we want to print all the elements in natural sorting order of their ID. And here we will be applying the terminal operation collect so that we can collect all the elements in another list. So collectors dot to list. Okay, and create one list here, list of employees, give it a name list2. Let's add some simple sysout statement so that we can print both the outputs. So sysout. Okay, this is a list2 sysout, and add a simple one for list1 also. It is a simple list. Okay, so our example is ready, and we will simply run it. So save the example and run it. Run as a Java application. Okay, so let's see what happened. and here we can see we are getting a class cast exception. We can see the list 1 is printed, but at the test2.java line number 24 we are getting an exception where we are trying to apply the sorted method, and the exception says, let's read the message here. It says employee cannot be cast to java.lang.comparable. That means our employee object is not comparable, and that's why we cannot use it as element in sorted method. So how can we resolve it? It has a simple solution, that we have to make our employee object comparable. And how can we make it? By just implementing a comparable interface to it and overriding a compare to method. So let's make it compatible. So we are at our employee object, and here I will add the comparable interface. So public class employee implements comparable, and what we are trying to compare? Employee. Okay, so we have added a comparable interface here, but as soon as you add a comparable interface, it says there is some compile time error, and once you hover on the employee, you will say add the unimplemented methods. That means the interface comparable has some method which need to be implemented. Here you can see that we are overriding the compare to method, and as we have discussed earlier in the example, that we will be comparing employees on the basis of their IDs. So I will say this dot get ID compare to O dot get ID. Now O is the object that we are passing, and this is the object that we are referring to. This is the current object represented by this, and the O is the one we will be passing. Okay, so we have overridden the compare to method. Save this employee object and we will come to test2. Let's clear the console and I will run it again. Okay, now you can see the list 1 and list 2 is printed. The list 1 is the one we have created. It has 101 Shubham and then 103 Gaurav and like 104 Radha and 102 John. But the list 2 is the sorted one. It has 101 Shubham and then 102 John. In case of the list 1, it is 103 Gaurav, but since the list 2 is sorted according to the IDs of the employees, it is 101 first, 102 second, and so on. You can see the output here. So that's it for the sorted method without parameter. We have seen two examples. The first one is with simple list of integers, and second one is with the custom object, which is employees. And we have checked the condition for class cast exception, and we have seen how can we resolve it. Okay, so we have seen sorted method which do not accept any parameter. But now we will see the sorted method which accepts a comparator object. We know that comparator object is used to provide custom sorting logic. So sorted method will return a stream consisting of the elements of this stream sorted according to the provided comparator. This is an intermediate operation. That means it will always return a stream. And this is the method signature. So let's see examples related to the sorted method which accepts a parameter. Okay, So this is the first example test, and here we have taken a list of integers and added numbers in a random order, and this is a list 2 for which we are just sorting using the simple sorted method which do not accept any parameter. And in case of this method, the elements will be always sorted in a natural sorting order, and we know that for integers the natural sorting order is ascending order. So let's simply run it and we will see if it is printing. Okay, we can see it is printing in natural sorting order. We have seen this example for sorted method, right? So we will improve it so that we can pass some customized sorting order. So we have printed it in ascending order. Now how can we print it in descending order? So for that we have a sorted method with comparator object, and we can pass the logic for our descending order sorting. So let's create one comparator from java.util, and we will be sorting integer. Let's say C. We know that comparator is a functional interface because it has only one abstract method. So let's see, it is compare. It has only one abstract method compare which accepts 2 parameters of any type. So here we will be writing a lambda expression for our logic. So if you are not sure how can we write lambda expression, I will recommend you to check my first video where I have explained very well how can we write lambda expressions for various cases. I have given the link in description. So here we will be taking 2 parameters as an input. Let's say I1 and I2. These are our 2 integers which gives, and here we will be expecting it to print in a descending order, and that's why I will take I2 compare to I1. Okay, now it is a logic for descending order, and here we will take a stream on our list. So list.stream, and here we will be using the sorted method with comparator object. So select the second one and press enter, and here our C is comparator object here. Okay, and this is an intermediate operation, so it will be always returning a string. To get our result we have to use the terminal operation which is collect, and here we will be collecting it to the list. So collectors dot to list. Okay, add the semicolon and let's collect it in a list. So list of integer, and I will give it a name list 3. Okay, save it, and we have a list 3. Simply add the print statement for list 3. Okay, save it. Now I will clear the console and let this program run again. Okay, so you can see this is the list 1, which is the simple random elements that we have added in the list. List 2 is the one where we have used the sorted method without any parameter. That means it will sort the elements in natural sorting order, and for integer the natural sorting order is in ascending. You can see 1, 2, 3, 4, 5 and so on. Now here we want to print the elements in descending order. And how can we pass the customized sorting logic to the sorted method? Using comparator. You can pass the comparator object as a parameter to the sorted method, and it will sort our elements based on the comparator. And at the comparator we have written a lambda expression which says print our element in descending order, and we have printed the list 3, and you can see the list 3 is printed in descending order, 10, 9, 8, 7 and so on. So this is the simple example for sorted method with comparator. We have seen it for numbers, integers from 1 to 10. But we have seen a second example for our employees class, where we will be printing our employees in ascending order of their IDs. So let's improve this example so that we can pass some customized sorting logic using comparator. So clear the console. Okay, and this is stage 2, where we have added some employees to the list, and in list 2 we are simply sorting it in its natural sorting order, and the employee class implements the comparable, where we are overriding the compare to method. So here it will print all the elements according to their IDs in ascending order. So let's simply run this program. Okay, you can see 101 Shubham, 103 Gaurav, because it is in random order since we have added it in random order at list 1. At list 2 we are sorting it in natural sorting order of their IDs, and you can see 101 Shubham and then 102 John and so on till 3, 4 and 5. Okay, so here we want employees to print in descending order of their IDs. How can we do it? We can use the sorted method with comparator. So let's create one comparator for it. Comparator of employees, because we will be comparing employee object here. See, and here we will be again writing a lambda expression. You can check the video and description how can we write lambda expression for various cases. So here I will be getting 2 parameters, let's say obj1 and obj2. Okay, it gives. Now here I will be writing a logic for compare method of comparator interface, and I want to print all the employees object in descending order of their IDs. So I will be checking object 2 first dot get ID dot compare to, and here we will be taking object 1. Okay, so this is the logic to print employees in descending order of their IDs. Okay, and here we will be taking a stream on list. So list dot stream, and the sorted method we will be choosing the second one with comparator presenter, and our comparator object goes here. Since this is a intermediate operation, it will always return a stream. To get our result we need to add a terminal operation, and it is collectors dot to list, because we want to collect it in a list. Okay, so let's create one list here, list of employee list 3 and list 3. Okay, save it. Add the simple sysout statement below list 3 so that we will be checking. list 3. Okay, I will clear the console and run this program again. Okay, see, now we will be seeing list 1 where we are printing the employees in random order as we have added in the list 1. Okay, at list 2 we have used the sorted method without any parameter. In that case, our employee class need to be implementing the comparable interface so that we can sort it. Otherwise, we will get an exception, class cast exception. We have seen this case in the previous example. Our employee object is implementing the comparable and we have overridden the compare to method so that our sorted method is working fine and we are printing the employees object in ascending order of their IDs, because sorted method will use natural sorting order, and sort with parameter as a comparator we can pass some customized sorting logic. In case of this example, we want to print employees in descending order of their IDs and we have written a logic for it. You can see this is the comparator that we have written and we want to print it in descending order of their IDs, and you can see the output list 3 is printing 105 Mike first and then 104 Radha and then 103 Gaurav, 102 John and 101 Shubham. So it is printing in the descending order. So I have shown you how can we pass the customized sorting logic using comparator, and we have printed the employees in descending order. So this is a simple example for sorted method with comparator object. In this video we will cover distinct method. A distinct method will return a string consisting of the distinct elements of this string. That means if I have a string of elements, the distinct method will return only distinct elements. That means unique elements. For duplicate elements, the element appearing first in the encounter order is preserved and others are removed. One thing to remember that the distinct method will use object.equals to check if the elements are equal or not, because it has to remove the duplicate elements, right? So it will check using equals method, and if it found the element is duplicate, it will preserve the first one and it will remove the remaining ones. It is an intermediate operation and you can see the method signature below. So let's take one example for the distinct method and we will understand it better. Okay, so here I will create one class and let's give it a name test. Add the main method. So we will be taking a list of integer which will have multiple duplicate elements, and we will try to get the distinct elements using distinct method. So let me create one list of integer, let's say list equal to arrays as a list, and here I will add numbers, let's say 1 to 10, but I will add in a random order and I will add duplicate elements too. Okay, so I have added multiple elements here and most of them are duplicates. Okay, so let me import the list, import list from java.util. Okay, and I will add a sysout statement here. let's print the list. Okay, and now we will try to get the distinct element using distinct method of the stream. So first I need to get a stream on the list. So how can I get it? List dot stream method. So now I have a stream and I can use the distinct method. You can see the distinct method and we will apply it. But now distinct method is a intermediate operation. That means it will return a stream. So to get the result, we need to apply terminal operation. And here we will be using collect method. And we will be collecting it in a list. So collectors dot to list. Okay. So create one list here of integer the list 2. Okay, and again I will add a sysout statement. So copy this, paste it here. I will make it list 2, add a new line and list 2. Okay, now save it and we are ready to run the program. And let's run it using run as Java application. Okay, you can see on the console the elements that we have added in the list 1, and it has multiple duplicate elements. But you can see the list 2, it has elements but all the elements are unique. That means you will find 3 but you will not find 3 multiple times, as we are able to see 3 multiple times in the list 1. In list 2, 3 is present only once, 4 is present only once, 5 is present only once. You can see above 5 is present 1, 2, 3 and many times. So as using distinct method on the stream, we are able to get the distinct elements. Till now we were covering intermediate operations, that means the methods that will return stream. But now we will cover some terminal operation, that means the methods that will return a result instead of stream. So the first terminal operation that we are seeing is count. As the name suggests, count method will return count of the element in this stream. And as we have discussed, it is a terminal operation. You can see the method signature, it is returning long. So we will see a simple example for the count method, and let's move to the Eclipse. I will create one class, add the main method. Okay, now here I will be taking a list of elements, let's say integer, and we will be counting the number of elements in the stream. So let me create one list of integer, let's say list, and okay, now here I will add some integers. Okay, so let's import the list. Okay, now we will get a stream of the list. So how can we get a stream of the list? List dot stream method, and now we can apply the terminal operation count. That's it. But as we know, the count method will return a long, so we will take one variable long count. Okay, and we will add a simple sysout statement for count. Okay, and I will add a sysout statement above so that we can simply print the size of the list. This is just for confirmation. There is no need for this, but we will confirm that whether the size and count we are getting the same. And here I will add. Okay, save the program and we will run it. So run as a Java application. Okay, you can see the list size is 7 and we have 7 elements in the stream. So it is perfectly fine example, and we have seen how can we get the count of the elements from this stream using count method. In this video we will see the collect method. Basically, collect method will collect all the elements of this stream using a collector, and this is a terminal operation, and you can see the method signature below. Since it is a terminal operation, it will return a result. So let's check out one simple example for the collect method. Okay, so let's create one class. I will give it a name test at the main method. Here I will take a list and I will add a few integers to it. So let me take list of integer. Let's say list and okay, so import the list. Okay, so we have a list now, and how can we get stream from the list? List.stream method, and let's apply a map. It will accept a function and we will pass a function as a lambda expression. So let's say I gives I multiply by, we will make a number double. If it is 2, we will make it 4. If it is 3, we will make it 6. Okay, now this is an intermediate operation map, and we need to collect it, and we know that collect is a terminal operation, so we can simply apply the collect and we can pass one collector. So let's say collectors dot to list. We have seen this many times, still we will see this. Let me take one list here, list of integers. We will call it a list 2. Okay, so we had a list of integers and we are applying some function on it using map method, and we are collecting it using collect terminal operation. Okay, so we can print it. Let me add a sysout statement, add a list 2 for now. This is the one way, but as you can see there are many collectors we can pass, and also we will see how can we get the data into the set. So I will get a stream first, list.stream, and then again collect. Now here we will pass collectors to collection. Here we will pass a collection to collection, and we can say like tree set and constructor reference new, so that we are creating a new tree set object here, and we are passing it to the to collection, because to collection will accept a supplier. You can see here it is accepting a supplier, and we are passing tree set object to collection method. Let's add the semicolon and get one set here, set of integer set. Okay, save it, import the set. That's it. Import the tree set. Okay, let me add the line here. Okay, it is looking fine now. Okay, so add the sysout statement for set 2. Okay, this is list, this is set. let's see how can we get it into a string. So basically we will convert these numbers into the string first, and then we will join it using the collect method only. So let's take list dot string, and now we need to convert these integers to string. So we can use the simple map, and here we can pass the function. Now in function we need to write a logic which will be converting our integer to string. So we can write I gives, and there is a value of method string dot value of, and we can pass I here. It will convert the I into string, and then we will apply collect and collectors. Let's take it below. Okay, collectors dot joining method. There is one joining method and one joining with char sequence delimiter. So we will be using this one, and here we will be passing one string comma space at the semicolon, and let's create one string variable so that we can store it. Okay, also print out this join variable. Okay, save it and we will run it. You can see this is the numbers that we have added to the list, and we are collecting it as a list. So it is list 2. Then we are adding the numbers to the set, and as we know, set always contain only unique elements. You can see 6 multiple times, but since we are adding it to the set, it will come only once, and you can see it is only once here. And then we are printing it as a string, and we are joining each element by comma plus space, and that's why you can see all the elements are joined by comma plus space, and it is printed as a string. This is how we can use the collect terminal operation. There are other use cases, we can explore it more. Now we will see toArray method. We have seen how can we get a set or string from set of elements, but if we want to convert a string of elements into an array, we can use this simple toArray method. ToArray method will return an array consisting the elements of this string. Of course, it is a terminal operation, and it will always return object array. This thing to remember, that toArray method without any parameter will return object array only. So we will see an example how can we get an array from the stream of elements. So let's move to the Eclipse. Okay, so let me create one class at the main method, and so here I will add one list, and we will add a few integers to it. So let's say list of integers list, and here arrays dot as list. Okay, here I will add few integers. Let's import the list. Fine. Okay, now I have a list of integers and it had some elements, but I want an array of elements which are greater than 3. So how can I get it? So let's get a stream of the list first, and we will get it using list.stream, and then let's apply a filter, since we are just adding a simple functionality that all the elements in the array will be greater than 3. So here I will be writing a lambda expression for filter, because filter accepts predicate, and predicate is a boolean valued function. So I gives I is greater than 3. So here input parameter is I, and it will check each element. If I is greater than 3, then it will pass ahead. And since filter is a intermediate operation, we need a terminal operation. And as I have told you before, that we are going to collect all the elements in array. So there is a method toArray, and we will be using the first one. This method will return an object array. One thing to remember is that irrespective of the element type, this is always going to return object array. So we will be creating toArray, and here let's declare one object array. Okay, now we will be having an array. So let's write a simple for loop, and we will be printing it. So object o up arr, add a sysout statement, and we will be printing it. So o dot toString method. Since it is an object, we will be using toString method to print it. That's it. Now this is an array, and let's try printing it first. So I will save it and I will run the code. Run as Java application. Okay, you can see that we have an elements, and it is in a list, and from that list we are getting an array, but it is an object array. So if I want to get an integer array, like since the elements are integer, I want this array to be integer array arr. So how can I get it? So let's check how can we get a specific type of array. So I want integer array arr2, and again we will add the same condition. Let's say list dot string, and the same filter. I will just copy paste it. Okay, now as we have said, there are two array methods. The one which will return object array irrespective of any element type or anything, but there is another method where we can pass a generator, and that generator will decide which type of array we are going to create. So we will use the second one here, toArray, and since we want it to be integer array, we will be adding integer array, and here we will be using double colon operator. Let me take it below. Okay, so here we will be using double colon operator and new. So this is the constructor reference we are giving to integer array, and it will act as a generator, and the new array that we are creating will be integer array only. We can print it by using the for each loop, and integer I arr2, add the sysout. Okay, print the I. We do not have to use the toString method because it is an integer only. So save it, and let me add some sysout so that we can differentiate between two outputs. Okay, save it, and we will run it again. So run as Java application. Okay, you can see the first one is from object, and then the second one is from our integer array. So this is an object array and this is an integer array. Basically we can create an array from string using the toArray method. And there are two types of toArray method. The first one is simple, which do not accept any parameter, but irrespective of any element type, it will always return object array. And the second one is toArray method, which will accept a generator. So you can pass like custom object array and new, or integer array and double colon operator and new. So it will accept an generator and will create an array according to it. And we have checked it by printing the elements. And today we will see a simple method, foreach method. Now, by reading the foreach name, you may be thinking of foreach loop. And you are right. The foreach method will work as similar as foreach loop. But there is a little syntactical advancement. We will check it in the example. Do not worry about it. So basically, the foreach method performs an action for each element of this stream. And of course, this is a terminal operation, and you can see the method signature here. The foreach method will accept consumer. Now we know that consumer is a predefined functional interface. It will accept a parameter and consume it. It will not return anything. And you can see here the foreach method has a return type as void. That means the foreach method will not return anything. Let's move to the Eclipse and we will see a complete example for the foreach method. Okay, so here I will create one class and add the main method. Okay, so here I will be taking one list and we will be adding a few integers to it, and then we will iterate over the list using for loop and then foreach method, and we will compare all three cases and you will get to know how foreach method will make your life easier. So let me take one list here, list of integer, let's say list, arrays as list. Okay, and here I will add some numbers. So okay, let's import the list. Click on the list and press Ctrl+1. You can see the suggestions, and then import list from java.ut. Add the semicolon. Okay, now we have a list and we will see the case 1 using for loop. Okay, so how can we iterate over list using for loop? We will write a simple for int I equal to 0 and then I is less than size of the list. So list dot size and I plus plus. Okay, we will add a simple sys out here, and here list dot get, and we will pass the I which is indexed. Okay, now this is the case 1. We will save the program and we will run it, run as a Java application. Okay, you can see we are able to print 1 to 10. This is using the simple for loop that we have learned many times. But after this for loop, we have a case 2 of for each loop, and here we can see case 2 using for each loop, or it is also called as enhanced for loop. And how can we write a for each loop? Simply for and then type of the element. So the type of the element will be integer, and here our variable I, and then colon, and then list, and in curly braces we can print this variable. So each element I will be printed from the list. We will save it, and let's add some sysout statement to differentiate the output. Also I will add the similar sysout above. Okay, now save and run as a Java application. Okay, You can see we are able to print it using simple for loop, and then we are able to print it using for each loop. And you can see the case 1 and case 2. This is the simple for loop that we have written, and this is the enhanced for loop or for each loop. But now we are seeing for each method of the stream in this video, and we will see how can we make this code in single line using for each method. So here case 3. So okay, so here we will be getting stream of the list. So list dot stream dot for each, and as we have seen, it is accepting consumer. Consumer is a predefined functional interface, and here we will be writing a sysout statement. For writing a sysout statement, we will be using method reference. Now println is the method and system.out is a class, and double colon operator is specifying that we are using the method reference. We will save it, and let's add a sysout statement to differentiate. Okay, now save the program and run as a Java application. Okay, you can see the output now. We are printing using simple for loop, and then for each loop, that is enhanced for loop, and using for each method. Now we are able to get the same result using all the 3 cases, and you can see the syntax for case 1, which is a simple for loop. Here we have to declare one variable I, and we will be incrementing I till the list dot size, and then we will be getting the element list dot get and passing that I index. Now this is simple for loop. This is the enhanced loop, where we are writing a simple syntax for each loop, and we will be printing the element. And this is the for each method. You can see we are simply passing our method reference here, or you can write a simple sysout statement, no issue. And we will be able to do these things in only single line, and the output is same for all the cases. So this is about the for each loop. Till now we have created stream from the collection, but is stream concept only applicable for collections? No, we can create stream from group of values or even an array. So stream class has a static method op, and this op method will be used to create stream of the group of values or an array. So let's say this op method. Stream.op method returns a sequential ordered stream of the specified values. This method is a static method from stream class. You can see the method signature here. It will return a stream of type P, and it will accept values. So these values could be, let's say, an array or a group of values, so that I can add multiple strings here, or integer or double, any type of values. So let's see a simple example for the stream.op, and we will understand it better. So here I will create one class. Let's say test, add the main method. Okay, so here we will be taking first a group of values. Let's say I will take some strings, and I will create a stream out of it. So we will be getting stream of string, yes, 1, and here we will be say stream dot of, and here we can pass values. So John, and the second value will be Mark, and third value will be Apeksha, and the fourth value will be Vikas. Okay, so I have created a stream of the group of values, and here the group of values are some strings. and I have s1 as a stream. Now once you have the stream, you can perform any stream related operation on that particular stream. So let's say I will print these names. So we have a for each method, and here goes the method reference. We will pass the sysout statement using method reference. So system.out will be class name, double colon operator which specifies the method reference, and method name goes here, println. That's it. We will save the program and run as a Java application. You can see we are able to print the names. So this is how we can get a stream from group of values using op method. Now we will check another case where we will be using an array. So here I will create an integer array, and here I will add some integers. Okay, now I want to get a stream of this particular array. So I will create a stream of integer, and here s2, it should be integer. Okay, s2 and stream of, and here we will be passing an array. So arr. That's it. We have a stream s2 with us. Now we can perform any stream related operations on the s2. So let's say I will print only numbers which are greater than 5. So how can we do this? So let's say we have a stream s2, and then we will be applying one filter, and filter accepts predicate. Now for predicate we will be writing a lambda expression. So how can we write a lambda expression which should have a logic like it should allow elements only greater than 5. So let's say I gives I greater than 5. Now here I is an input parameter, and here we will be checking our logical condition, because we know that predicate is a boolean valued function and filter is an intermediate operation. So we need some terminal operation, and here we will be printing the numbers. So for each, and here we will be passing method reference to print like we did in the line number 12. So system.out double colon operator and method name. That's it. Save it, and we will be able to print numbers which are greater than 5 from this particular array arr. So let's save the program and we will run it. Run as a Java application. Okay, we are able to print the names from our line number 12 statement, and we are able to print numbers greater than 5. So you can see it is only printing 6, 7, 8, 9, 10. It is not printing numbers like 5 or less than 5 because of our filter logic. So that's it for the op method. We have seen how can we create stream from group of values. Here we have passed group of values as a strings. You can pass any type of values here. And second, we have seen how can we create a stream from array. So we have taken an integer array arr, and we have created a stream out of that array, and then we can apply any stream related operation. So we have added a simple filter, and we have printed the numbers. That's it. So let's see you in another video with some new concept. Today we will see one of the most important Java 8 feature, and it is optional class in Java 8. In day-to-day programming, we are dealing with null pointer exceptions. Usually, we will use if statement to check if the variable is null or not. and then we will process it. But this is a really tedious job to do null checks every single time, and that's why there is an optional class to help us deal with null pointer exceptions in a better way. If we have a variable and which could be null, we can create an optional of it using optional.ofNullable method. Then we can check if the value is present or not using isPresent method, and if the value is present, we can use get method to get the value. But sometimes we want to set a default fallback value. If my variable is null, then I should have some default value, and we can use or else method to set a default fallback value. Do not worry about it. We will see a complete example where we will be using these methods. So let's move to the Eclipse. Here I will create one class. Let's give it a name test, add the main method. Okay, so here we will be creating an optional of the string. So let me create one string. Okay, so we have a string and we need to create an optional. So we will be creating optional of string, and we will give it a name opt, and here optional of Java 8 optional, and we will be creating of nullable, and here we will be giving name. So this is the string name, and we have created opt optional of it. So we can print it. I will add a simple sysout statement and opt.get. Okay, and save the program, and I will run it. This is fine. It is giving mark because we are creating optional of the name. But let's say what if the mark is null? So let's check. I will make it null and I will comment the mark. Okay, now we will check what will happen. And it is giving an exception. Of course, this is not a null pointer exception, but it is another one which is saying no such element exception, no value present. That means our optional do not contain any value. So we should check the optional if it is containing any value or not. And how can we do it? Using isPresent method. So I will add a simple if here and opt.isPresent. Let's add a curly braces. Okay, so here I will be checking if my optional contains any value or not. If it is containing any value, we will print it, and we will add an else statement where if the value is not present, we will print simply default value, or let's say the opt is null. Okay, and I will save the program and we will run it again, run as Java application. Now we are getting default value because opt is null, because we are able to check opt is null or not, whether it is containing any value or not. And I will remove the null and comments to. Okay, now let's save the program and run it again, and now this time it will print mark because it is checking if opt is having a value or not, and this isPresent method will return true if the opt is having value. And this time we are creating opt of the name, and name has mark, so isPresent method will return true, and we are able to print value of the opt, which is mark. But this is fine, and it's again becoming lengthy. So in the beginning we have discussed that we want to shorten the code and we want to deal with null pointer exception in better way. But why it is getting lengthy then? There is another method, or else. Let's say I have a string name which has mark, but if it is coming from somewhere else, we don't know whether it is null or not. Then how can we set a default fallback value for it? We can do it using or else method. So let's remove this thing because we do not need this thing, and instead of optional we just need a simple opt string. So it will be string, opt string, and here we are saying that create an optional of the name, but if the name is null, I want or else, and here we can pass default fallback value. Okay, so I'm creating an opt string. It will have the value of name, and if the name is null, it will have default fallback value. So let's print it. I will add a simple sysout and we will be printing opt string. Save it and run the program. We are getting mark because we have a valid string name and it has mark. But let's say if name is referring to a null value, and I will assign it to a null value. Now what will happen? We will be printing a default fallback value. Let's check it. So clear the output and we will run the program, run as Java application, and you can see it is printing default fallback value. Now this time we don't have to add if statement and we have to check optional if present, and if it is present then we are getting, and otherwise else statement is executing. Now we do not want to do all these things, and we can simply check if null has a valid value, we will assign it to the opt string, or else we will assign the default fallback value and our opt string can be processed further. Now this is all important things about the optional, and we can use optional in our day-to-day programming to deal with null pointer exceptions in a better way. In previous video we have seen optional class from Java 8. Now we will come back to stream methods and we will see some terminal operations again. This time we will see the min and max method. These are two simple methods from the streams and we will see both one by one. So the min method returns the minimum element of this stream according to the provided comparator. This is a terminal operation and you can see the method signature for min method. You can see it is accepting an parameter comparator. So it will accept an comparator object and it returns optional of the type T. Since we have covered the optional in previous video, you may be familiar with it. Otherwise, you can check the I button or link in the description. The next method is max method, and as per the name suggests, the max method returns the maximum element of the stream according to the provided comparator. This is also a terminal operation and you can see the method signature for max below. It returns optional of type T, and as similar to the min, it will also accept a parameter comparator which is a comparator object. So this is the min method and max method. Let's see a simple example for min method and max method and we will understand it better. So let's move to the Eclipse. So here I will create one class and let's give it a name test, add the main method. Okay, so here we will be creating one list of integers and we will be finding the min and max from it. So let me create one list of integers. Let's say list, and here arrays as list. Now here I will add few integers. Okay, let's import the list. Okay, now we have a list of integers. These integers are not sorted, that means they are in a random order, and we need to find the minimum element using stream min method. So first we will get a string of the list. And how can we get stream from the list? List dot stream. Now we will apply the min method, and we know that min will accept a comparator object. Now here we will be using comparator dot natural order method. So natural order. This natural order method will return a comparator which will compare all these elements in natural order. And we know that min will return an optional. So we need to create an optional here. Optional of integer. Let's say min, and okay. So we know that optional has a get method which will get the value from optional, and we will add a sysout here and min dot get. Okay, save the program and run it. Run as a Java application, and that's it. You can see 1 is printed on the console, which is the minimum value from all the elements present there. Now this is how the min works. Now we will see max. So how can we max? It is very much similar to the min, just instead of min we will be applying to the max. So we know that max also returns an optional, so we will create an optional first. Optional of integer, and let's say max, and we will get a string from the list. List dot stream and max. Max also accept comparator, and we will use the same natural order method here too. Comparator. Okay, and natural order. That's it. Okay, so we will add a sysout statement here to max dot get. Okay, run it, and we will run as a Java application. You can see the max value is 10, the min value is 1. Okay, and this is how the min and max works. We are seeing some intermediate operations and terminal operations on the stream. So before wrapping up the stream concept, let's cover this important method, flatMap. The flatMap method is used to flatten the stream of collections to stream of objects. So let's say I have a list of list, and when we get the stream on that list, we will get a stream of collections. But if we want to get stream of all the individual elements, we should flatten it first, and the flatMap method will help us to do so. So basically flatMap method will work as flattening plus map method. This is an intermediate operation, and you can see the method signature here. Let's cover a simple example for the flatMap, and we will understand it better. So let's move to the Eclipse. Here I will create one class at the main method. Okay, so here we will be creating some list of integers, and then we will create a list of list. So the first one will be list of integer. Let's say list 1. Okay, so we have created a list of integers 1 2 3. Let's import the list from java.util. Okay, now we want 2 more lists. You can create multiples, but this time let's take 3 lists. Okay, rename it to list 2 and this one to 3. Okay, and the number should be like 4 and this should be okay. So we have a 3 different list which contains all the different elements. Now we will create a list of list. So list of list. Okay, list of list, and arrays as list, and here goes list 1, list 2 and list 3. Add this semicolon. Now we have individual list and we have created a list of list. Now let's take a string over list of lists. List of list dot string. Okay, and let's say flatMap. Okay, now this list of list has a list as an element, but we want 1, 2, that is integer as an element. So how can we get it? Using flatMap method. So it will flatten all the elements of different list into a single collection. And how can we do it? So let's say this x is a list and x gives x dot string. So list 1 stream will be this one, x dot stream. Then at second it will be list 2 dot stream, and at third list 3 dot stream, and we will collect it to the another list. Because flatMap is an intermediate operation, so we need to apply a collect terminal operation. So let's add it below. I will enter, and here collectors dot to list here. Okay, and let's declare one list here. So list of integer, let's say new list. Okay, so let's add a simple sysout statement so that we can see the output. So sysout for list of list, and I will copy it. Okay, and add the similar sysout for new list too. So here goes new list. Okay, I will save the program and we are ready to run it. So run as Java application. Okay, now observe the output. Now this is list of list. So you can see an individual list of 1, 2, 3, 4, 5, 6, 7, 8, 9, and this is the main list which contains this 3 individual list. This is our list of list. But when we apply the flatMap method, it will simply flatten all the elements into a single collection, that is new list. So this is how the flatMap method works. Today we will see date and time API in Java 8. Till Java 7 we have date class, calendar class and timestamp class. But these classes were not convenient, and that's why language designers have added this new API, Java 8 date and time API. This API is also known as ZonedDateTime API. These are few important classes from Java 8 date and time API, and we will see all these classes one by one. So let's see the first one, which is LocalDate, and we will directly see a few examples so we will understand it better. So let's move to the Eclipse. Here I will create one class and let's give it a name LocalDate example. Add the main method. Okay, so now we will see how can we print a current system date. So I will write a class here, LocalDate, and let's say date LocalDate. It has a static method now and it helps us to print the current system date. We can save it and let me print the date. Okay, save it and run as a Java application. Okay, now we are able to print the date, but let's say I want to get a particular day of the month or month value or year. So we will see how can we get it. So first I'm getting day, and we have a method which will be get day of the month. You can get day of the year also, but in this particular example we will get day of the month. And then you can get the month value, and it will be date dot get month value. And then I want to get an year value, so there is a simple method get year. Let's add a sysout statement for it, and okay, we have added a sysout statement too. Let's save it and run again, and you can see the date is 2, the month value is also 2, and the year value is 2022. This is how we can use the local date. And now we will see the local time class. So let's move to the Eclipse and we will see the local time class. So here I will create one class, and this time give it a name local time example. Add the main method. Okay, so if I want to get a current system time, how can I get it? Using the static now method. So let's write local time and local time dot now. Okay, and let's add a sysout statement to print the time. Okay, save the program and run as a Java application. You can see it is printing time, and it is also printing the nanoseconds, seconds, minute and hour. So if I want to get an individual value, like I want to get an hour value only, or I want to get an minute value only, or I want to get a second value or nanosecond value, so how can we get it? So let's check it. So here I will be getting an hour value. So int h is equal to time dot get hour. This is a simple method to get an hour value. Save it. Now if I want to get a minute value, there is a simple method time dot get minute, and you can get minute. Similarly, you can get the second value time dot get second, and we can see the nano here in the time. We can get it using int n time dot get nano. So these are the simple methods to get an individual value of the time. And let's add a simple sysout statement so that we can check it. Okay, so we have added a sysout statement for individual values, and let's save the program and we will run it. You can see we are able to get the individual values, like hour is 9, minute is 35, and second is 25, and the nanoseconds here. In the previous video we have seen local date class and local time class. These both the classes will help us to print the date and time respectively. Now if you want to deal with date and time in a single class, there is a local date time class, and we will see it. So let's move to the Eclipse and we will see this class. So here I will create one example class and let's give it a name, LocalDateTime example. Add the main method. Okay. Now if we want to print the current system date and time, we can use the static method now. So let's add local date and time. Let's say date and time dot now. Okay, let's add some simple sysout statement to print it. Okay, save the program and simply run it. Run as a Java application. Okay, you can see the date and time is printed on the console. But as we have seen in the previous examples, we were able to get the individual date and month, year, hour, seconds, all the individual values. So like how can we get the individual values from date time? So let's check it. So for date, let's take int day, and here we will be using the same method that we have used previously, and it is get day of the month. For month value, we have the same method, get month value, and for year we have the same, get year. Okay, you can see these are the same methods, but the reference object is local date time here, and we are invoking the same methods that we have used for local date. We can add a sysout statement here, and okay, I have added the sysout statement. Let's save the program and run it. Yeah, this is the date and time, and we are getting the individual value for date here. But what about the time? We are also able to get the individual values of time also. So let's check how can we get it. And since we have used the similar method for date, we are also able to use the similar method for time. So let's say hour, and here get hour. This is the same method that we have used for the local time class, but the reference class here is local date and time. And for minute, we will be using date time dot get minute. For second, we will be using the second get second method, and for nano, we will be using date time get nano. Okay, so we have used the same method that we have been, so we have used the same methods that we have previously used in local time example. Let's add the sysout for these two, and okay, so we have added the sysout statement here for all the individual time values. Save the program and run as a Java application. So you can see this is date and time that we have printed from the line number 11, and these are the date individual values that we are able to print it here, and then it is the time individual values like hour, minute, second, and nano. So this is the local date and time class. we know that we can use the now method to get the current system date and current system time. But if I want to represent a particular date, how can I do that? Let's say I want to represent 20th May of 2000, this date, using local date time. So how can we do that? We can do that using of method. There are various versions of the of method and we can use it to create our local date time. So this is how we can represent a particular date. But let's say I want to represent a date after 6 months. How can I do that? Then we can use the plus and minus method. We can use plus and minus method to add or remove the particular period of time from the local date time. So let's say you can check the example here. Like I want a date after 3 months, then I can use plus month method and I can pass the value 3. Let's say I want a local date time object of before 2 months, I can use the minus month and pass the value as 2. And so there are similar methods for days, years, weeks, hours, minutes, seconds, and even nanoseconds. So we will see a simple example and we will see how can we represent a particular date using local date time. So let's move to the Eclipse. So here I will create one class and let's give it a name, particular date example. Add the man method. Okay. So here I want to represent a date of, let's say, 20th May 2000 and time could be 10, 20, 46. Okay, so how can we represent this particular date using local date time? So I will be writing local date time, let's say dt, and local date time of, and here you can check the various versions of the of, and it will allow us to pass the year, month, day, hour, minute values. So we will choose the one and you can see the first one is year. Like you can see the value is in bold and we will pass it like 2000, right? And we want the month as May, so we are passing the value as int, so we will be passing it 5. And then date, so we want 20, and here goes the time, so it is an hour, and here goes the minute, 20. So if you want to pass the seconds value, you can pass the second after minute. So it will be year value, it will be month value, it will be day of the month, it will be hour, it will be minute, it will be seconds. Add the semicolon and we have our dt. Simply add the sysout statement and we will print it. Let's add this also. Okay, save the program and run as a Java application. You can see this is the date that we want to represent, and here you will see the exact date as a local date time. You can see the year is 2000, May, that means 5, and 20th is the day of the month, and here the day of the month is 20th, and you can see the time here exactly same. This is how we can represent a particular date using local date time. So now I want to get a date after 3 months. So we will be getting a current local date time and we will be adding 3 months to it. How can we do it? Let's check. So we want to get a date after 3 months. So before we will get the current system date time. Local date time, let's say dt2, and local date time using now method. Okay, so we have a current date and time. Now we want to get our date after 3 months. So we will be using local date time, let's say after 3 months, and here dt2 dot plus months, and you can see here it is a plus month method. We will be passing a value and it will be 3. Let's add a sysout statement so that we can check after 3 months. Also add the sysout for current date time. Okay, so let's add the new line character. Okay, and run it as a Java application. Okay, this is the date that we want to represent and the output for the line number 13. Now here we want to get a current local date time, and for line number 17 the output is this one. You can see the current date and time. Now I want to get a date after 3 months, and we have used the plus months method, and you can see here it is after 3 months. This is an year, this is the value for month, it is February 02, and after 3 months it is May, that is 05. You can clearly see it is giving a date after 3 months. Now let's say example for before, and we will be using before 2 months. Okay, similarly I will get local date time here, and here I will be using minus and month, minus months, and the value will be 2. Add the semicolon, and let's add a similar sysout statement. Okay, save the program and we will run it again. Run a Java application. Okay, you can see this is the date that we want to represent particularly. This is current date time, this is after 3 months, that is May 05, and this is before 2 months. I want to get a date before 2 months, so it is February 2022 and the date is 3rd. You can see the date is similar 3rd, but we want to get it before 2 months and it is December, and the year is 2021. So we are getting the date before 2 months. So this is the similar example where we have checked for after 3 months and before 2 months, but there are similar methods that are possible to use for getting after hours, before hours, after weeks, before weeks, after minutes, before minutes, after days, before days. There are lots of methods, and you can check all the available methods here or in the API. In this video, we will see how can we calculate an amount of time between two dates using period class. Period class represents date based amount of time such as 2 years, 3 months and 4 days. If we want to calculate the amount of time between 2 days, we can use period class methods, and there are such methods like between, where we can pass 2 dates and we will get the amount of time between these 2 dates, and we will get it in years using get years, or in months using get months and dates. So let's see an example for the period class, and we will move to the Eclipse. So here I will create a class, add the main method. Okay, here, so let's calculate our age. So age calculate. Okay, so we will be calculating the amount of time between 2 dates. So let's say someone's birth date is like 1st of January 2000, and we will be calculating his age now. So let's create one local date dt local date of, and we will be passing year, month and day of the month. So let's say it is 2000 and it is 1, and again it is 1. Okay, so and we want to get his current age, so we will be getting a current local date. So local date dt2 local date dot now is a static method that will help us to get the current system date. Okay, now we will be calculating age, and we have a period class with us. So period p, and here period between dt1 or dt2, add the semicolon, and let's add sysout statement. So we will be getting years first, so add the p dot get years here. Okay, and add it for months and days. So here it will be months and here it will be days. Change the method to get months and change the method to get dates. Okay, and we will save the program and simply run it. So the date of birth is 2000 1st of January, and this is the local date, current system date, and we are getting his age. So it will be 22 years 1 month and 2 days. So the age of the particular person will be 22 years 1 month and 2 days, and this is how we can calculate age. Basically we are calculating amount of time between two dates using period class. In this video we will see duration class, and duration class represents a time based amount of time such as 34.5 seconds. There are some duration class methods that we can use, like 2 millis, get seconds, 2 hours, 2 minutes, and the one is between that we have also used in period class. There are some duration class static methods that we can use to create durations such as off and off hours, off minutes, off days. So we will try to see all these methods in the example, and let's move to the Eclipse. So here I will create one class, add the main method. So as we have seen, duration is a time based amount of time. So here we will be creating two local times and we will try to calculate duration between them. So local time ELT, local time of now. So we will be taking a current system time, and let's create another local time ELT2, local time of, and here we will be passing hours and minute. So let's say 20 and 30, that is 8:30 p.m. Now we will calculate duration between these two local times. So duration D equal to duration, and we will be using between method, and we can pass LT and LT2 here. Now we can use some methods to print the duration in readable format. So we will add some sysout statement. Okay, so we have added 3 sysout statement, and we are printing the complete duration between LT and L2 in hours, in minutes, and in seconds, and we have used the respective methods. So let's save the program and we will run it. So run as a Java application, and you can see it is printing duration between LT and LT2. In hours is 10 hours, in minutes it is 659 minutes, and in seconds it is 39560 seconds. you need to make sure that we are referring to a complete duration between LT and LT2. So in seconds, it is a complete duration between LT and LT2. In minutes, it is taking a complete duration between LT and LT2. So this is how we have printed duration in some readable formats. There are other methods too. You can refer the Java doc. Also, we have discussed that we can create duration ourselves, and there are some methods which will help us to create the duration. So let's check these methods. So I will create a duration d2 here, and here we will be using off method. You can check the off method. It is accepting a long amount and a temporal unit. So we will be passing the amount 1. I need to create 1 hour of duration, and that's why here we will be using ChronoUnit dot hours. Do not worry about the ChronoUnit class. We will cover this class in next upcoming video. And hours is a unit here. There are multiple units available in the ChronoUnit class. Okay, so again we will create some duration d3, and here we will be using duration of hours. You can see there are some ready-made methods that can be used to create a duration of any particular units. Let's say I want to create 1 hour of duration. So in first case, I have used the off method where we need to pass a value and a unit. In second case, we will be using a ready-made method, and it is off hours. There are multiple methods like off days, off mileage, off minutes, so you can use it by your choice. Okay, let's add some similar sysout statements, and I will be using it in minutes. So okay, let's add a new line here. Okay, now run as a Java application. You can see these are the 3 statement, duration between LT and LT2, and we are printing the complete duration d2 in minutes is 60, because at final we have created 1 hour duration, and the d3 is 1 hour duration using off hours method, and that's why it is in minutes it has a 60 value, and in minutes d2 also has a 60 value. So this is how we can use the duration class. This time we will see an enum, and it is a ChronoUnit. We can use ChronoUnit.between method to calculate the difference between 2 dates or 2 times. The ChronoUnit enum has multiple units, and you can see it in the second points, and we can use these units to calculate the difference between 2 dates. Let's say I have 2 dates and I want to calculate the difference in weeks. Then I will be using ChronoUnit.weeks.between, and I will pass these 2 dates as a param. Similarly, you can calculate these differences in centuries, in days, decades, seconds, minutes, and so on. You can use all these units to calculate the difference between these 2 dates. So let's see some simple example, and we will try the important units of ChronoUnit. Okay, so here I will create class, and let's give it a name ChronoUnit between example. Add the main method. Okay, so we are going to calculate the difference between 2 dates, and let me take one LocalDateTime here. LocalDateTime from java.time, and let's say it is LT. Okay, so we will use the off method so that we can take some previous dates, and let me take 2014 here, May, and the date is 16. Okay, time, let's say 15 and 30. Okay, so 16th of May 2014, and the time is 15 hours and 30 minutes, that is 3:30 p.m. Okay, now this is my first local date time, and I will take another local date time LT2, and this time we will use the now method. That means we are taking the current system date time. Okay, and now I want to calculate the difference between LT and LT2 using ChronoUnit. So let's take ChronoUnit, and here it is java.time.temporal ChronoUnit dot, and first I will calculate the difference in years. So years dot between LT1 LT2. Okay, and once you hover on the between, you can see the return type of this method is long. So we will add long here, years, and equal to. Okay, so we will be get difference between these two dates in years using ChronoUnit dot years dot between. Similarly, we can take it in months. So long months between LT1 LT2, and also we will be able to get it in weeks. Okay, and then we will get it in days. So long days ChronoUnit dot days and between. Now we will get the difference in hours. So hours ChronoUnit dot hours dot between and LT1 LT2 as a para. So after hours we will get the difference in minutes dot minutes dot between LT1 LT2. Also we can use millis and seconds too. So let's take second first. Seconds ChronoUnit dot seconds dot between LT1 LT2. Now we will take it in millis, and let's say ChronoUnit dot millis and dot between LT1 LT2 as a parameter. And let's take the final nano. ChronoUnit dot nanodes dot between LT1 LT2 as a parameter. Okay, so we have calculated the difference between LT and LT2 in different units, and let's print all these values on the console so that we can check it. And so I will add the sysout statement for every single value here, and you can check the values on console after running the program. So let me add it. Okay, so I have added all the sysout statement, and we will run this program. So run as Java application, and let me make it Okay, and you can see the difference between LT1 and LT2 are in years it is 7, in months 92, in weeks 403 weeks, and in days, hours, minutes, seconds, millis, and nanos. So this is how we can get the difference between LT and LT2, that is two date and times or two individual dates or times, using the ChronoUnit dot between method, and we can use all these units to get the difference in the particular units. Today we will see the instant class. Basically, instant class is for representing the specific timestamp at any moment. This class represent an instant in time to an accuracy of nanoseconds. Instant class supports the plus, that is adding, and minus, that is subtracting operations that we have already seen for duration class and period class. And we can use now method to get the current instant timestamp. So we will see a simple example in Eclipse, and we will see how can we print the current instant timestamp, how can we add time to it, how can we subtract a particular time from it, and how can we print the epoch seconds and epoch milli from instant. So let's move to the Eclipse. Okay, so here let me create one class and add the main method. Okay, so here I will create one instant and it should be the current system instant. So instant from java.time, let's say it instant dot now. This is the current system instant and we will print it. So let's add a simple sysout statement and I will print it. Okay, now this is the current system instant and we are printing it as a timestamp. So there are other methods that will help us to get the epoch seconds from instant and epoch milliseconds. And whenever we are using Unix based system, we need the epoch time in seconds or in millis. So let's see how can we get it. So let's see how can we get epoch time in seconds and millis from instant. So it is an instant and let's see long epoch seconds it dot get epoch second. This is the method, right? And we will print it. So system dot out dot println and epoch second. Also we will get the epoch time in millis, and there is another method called it dot to epoch millis. Right? Let's store it in a variable long epoch millis. Okay, and let's add a sysout statement. Okay, so we have epoch seconds, epoch millis, and let's do a subtraction and addition in the instant time. So let's add a sysout statement. So here we will be adding 50 seconds to the current it, and we will use plus method and it will accept a temporal amount and it will be duration. So duration of seconds, because we want to add 50 seconds and we can pass a simple 50 value here, right? And we are printing it. Similarly, I want to subtract some 3 minutes from the current it, so I will use the minus method and here of minutes, so of minutes, and the value should be 3 because I want to subtract 3 minutes. That's it. Let's add some sysout statement so we can see a little better output on the console. So I will add it. Okay, so we are ready to go, and I will save the program and we will run it as Java application. You can see the current system instance timestamp is as it is given on the console. It is 17th of Feb 2020 and the time is 5:30 and 53 seconds. The time in epoch seconds is this one that start with 16:45 and end with 58:53. In epoch millis, that means there should be 3 digits extra. So this is 13 digit. You can remember this thing that epoch millis will be always in 13 digit and epoch second will be in 10 digits, and you can match this with the instant timestamp that it is 53 seconds. So it is here 53 till seconds, and if it is till milli, you can see the 6 to 1 is the amount in millis, and here it is 6 to 1, and the current timestamp plus 50 seconds. So basically it is 53 seconds, 30 minutes 53 seconds, and when we add 50 seconds to it, it will become 31 minute and 50 and 43 seconds. And here we have minus 3 minutes, okay, from current instant timestamp. So the current instant timestamp is 30 minutes 53 seconds, and when we do the subtraction of 3 minutes from it, it will become 27 minutes and 53 seconds. So that's it, and this is how we can use the instant class from Java 8 date and time API for our various use cases. The most important use case is you can easily get the epoch second and epoch millis from instant class. Now we will see ZonedDateTime. Whenever we need internationalization of date and time, we should go for ZonedDateTime. ZonedDateTime is a date time with a time zone in the ISO 8601 calendar system. You can see the example on screen to understand how it will look like. Now this is the time and this will be the zone ID. So to specify a particular zone, we can use the zone ID class. You can see some zone ID examples, and now I am on the zone ID Java documentation. These are a few examples given here, but there are a lot. So let's move to the Eclipse and we will see a good example for ZonedDateTime. Okay, so I will create one class here and let's give it a name, ZonedDateTime example. Add the main method. Okay, so here we will be printing the zone ID as well as ZonedDateTime. So I will be printing the current system default zone ID first. So I will write zone ID, let's say ID, zone ID, and there is a method system default. So it will print the default zone ID. Let's add a sysout statement and ID goes here, save it, and we will run it as a Java application. Okay, it is printing the current system zone ID and it is Asia Kolkata. Now let's print the ZonedDateTime for this particular zone ID. So ZonedDateTime from java.time and ZDT time now, and let's pass the ID here. Okay, you can see there is a method. Now let me show you. You can see This is the method now, and it will accept zone ID. Okay, and I will print it. Okay, so this is the current system default zone ID and current system zone date time. But we can use the local date time to get the similar output, right? But we can also use the local date time class to get the output of current date and time. But the purpose of this zone date time class is to get the time from particular zone. Like you can see, it is specified here that it is a time for Asia Kolkata zone. But what if I want time for America Los Angeles zone? So let's create a zone ID for America Los Angeles. So zone ID, and let's say ID 2, zone ID of, and you can pass a string here. So let me pass America / Los Angeles, and now I will create a zone date time. Let's say ZDT2, now ID2. Okay, and add the similar sysout statement. Now I will add a few sysout statement so that we can differentiate between the current time and zone date time for Los Angeles. So here I will add okay. Now I will run a Java application, and you can see this is the current system default zone date time, which is for Asia Kolkata zone, and we have printed for America Los Angeles zone. So you can see the difference between time here. This is how you can get the zone date time for various zones and various zone IDs available. We have seen many classes like LocalDate, LocalTime, and LocalDateTime. But how can we format these classes? Before Java 8, we know that we were using simple text formatter, and simple text formatter was used to format date and calendar classes. But in Java 8, there is a specific class, DateTime formatter, and this class is a formatter for printing and passing DateTime objects. We can use the various string patterns to format the DateTime objects. Now I am at the documentation of the DateTime formatter class, and you can see the various patterns are given here. These are the symbols, and by using these symbols you can create various patterns. So let's take a simple example for DateTime formatter, and we will actually format a local DateTime. So let's move to the Eclipse. So here I will be creating one class. Let's give it a name, DateTime formatter example. Add the main method. Okay, so here I will be printing a local date time, and we will see how it will look like on console, and then I will format it in a particular pattern. So let's take a local date time from java.time, and let's take a current system local date time. So I will be using now. Add a sysout, and dt goes here. Okay, so this is a local date time that we are printing, and now add a date time formatter by using which we will be creating a particular pattern. Okay, so date time formatter, and formatter equal to datetime formatter. Okay, and I will be using off pattern. Okay, so I have just taken it on the next line so that you can see it clearly, and here I will be writing a pattern. So let's write a simple ddmmyy pattern. And yes, okay, this is a simple pattern. Okay, now our formatter is ready, and let's format the previous local date time that we have printed above. So formatter dot format, and dt will go here. You can see the format method will return a string, so we will write one variable string, and let's say it is dt formatted. Okay, this out and dt formatted, save it. So let's add some simple empty sysout so that there is some difference and we can differentiate between two dates. I will run as a Java application. Okay, now this is a local date time, that dt we are printing on line number 11, and this is the formatted one. So you can see the date is same, but we have formatted it as we wanted. So this is the pattern that I have used, and I have shown you many symbols in the documentation. You can use these symbols to create a pattern you want. So that's it for the datetime formatter video, and we have covered most of the important things from Java 8 datetime API. Okay, so we have covered all the important topics from Java 8 feature, and thanks for watching. We will connect again with new videos. Thank you.